Hello everyone, it's March 31st. Yesterday was a terrible one. We spent more than 3 hours. So I think from now on, if I couldn't get it, say, in over an hour, I think I'll just go for the solution. There's no benefit of stuck in a problem for 3 hours. Anyway, let's check it out, what we have today. Sampling the sequence. Okay. We want to form a target string of lowercase letters. I want to form the target. At the beginning, your sequence is target.length question marks. Okay. You also have a stamp of lowercase letters. On each turn, you may place the stamp over the sequence and replace every letter in the sequence with the corresponding letter from the stamp. You can make up to 10 times target length turns. Okay. For example, if the initial sequence is all question marks and your stamp is ABC, then you may make ABC, 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 okay? In the first turn, note that the stamp must be fully contained in the boundaries of the sequence in order to stamp. Is that considered one turn? You may place the stamp over the sequence and place every letter in the sequence with a corresponding letter from the stamp. Okay, that's considered one turn. If the sequence is possible to stamp, then return an array of the index of the leftmost letter being stamped at each turn. If the sequence is not possible to stamp, return an empty array. For example, if the sequence is this and the stamp is ABC, then we would return the answer 0, 2 corresponding to moves. So ABC as 0. No, it's ABC. ABC 0, 1, 2. Okay. I don't quite get it still. We can stamp it making these in the first turn up to 10 times target.length turn. So that's 5. So we're into 50 turns. So we can do it 50 times. Also, if the sequence is possible to stamp, it is guaranteed it is possible to stamp within 10 times its turns. Any answers specifying more than this number of moves will not be accepted. Okay, if we do this, we stamp. No, that's not the first turn, right? Oh yeah, that's the first turn. I thought they can do all 3 in the first turn. No. This could be the first turn, this could be the first turn. So each time you stamp, that's a turn. So you only have 10 times target.length stamp, turns, okay? So we want to stamp it. And did I say sampling? No, it's stamping. So we're going to stamp it and try to see how many, basically just how many times you stamp in order to get the sequence out. Do we know the target? We know the target. So we know the target and we know the stamp. And we want to know the sequence, right? To return the answer. So basically the moves. We want to know the moves that's needed to stamp the target. Okay? We say this one 1, 0, 2 is also accepted. So 0, 1. So we do ABC here. How is 1 be accepted? Because we're going to return it's possible to stamp and return an array of index of the leftmost letter being stamped at each turn. How is the leftmost letter is 1? It's this one being stamped. So like AB, we know AB, so leftmost is 0, and then we stamp here, it's going to be 0, 1, 2. How can it be 1? Okay, so we do ABC, we do here. The leftmost. How is it be 1? AB, the leftmost, should be 0, right? I don't understand this. Then we could return the answer 0, 2, corresponding to move, these two moves. So after we stamp these guys, we have this, and then we stamp again, right? Would also be accepted as an answer. How? How is 102 is an answer? It says the leftmost letter. How can this be the leftmost letter? BA. I don't know. I don't understand this one. It says 102. Like 0 I understand. 2 I understand. 1 I do not understand. How do you do 1? Alright, just don't worry about it. 0, 2. We got 0, 2. And here, let's see. A, we can stamp the first one. A, B, C, A. So we have 1. And then we do A, B, C, A. We have 2. And then we do here A, B, C, A. 0, 1, 2, 3, 4. 5. We do 5. This is 3, 0, 1. 0, 1, 0, 1, 2, 3. So this is the first thing getting stamped. Huh? Wait, what? How is this 3, 0, 1? Read it again. If the sequence is possible to stamp, then return an array of the index of the leftmost letter being stamped at each turn. Oh, the leftmost being stamped. So it's not the one that's matching. Ah, it's actually the thing. So basically this is saying we're going to stamp here first. This is 3, and we're getting these 2. And then we stamp here. We're getting A. And then we stamp here, we're getting the rest. In that case, we're just saying we do ABC here, ABC. We stamp here, which doesn't give us anything. Didn't give us anything, and then okay, now I got it. Now I got it. It makes sense. So the returning is the being stamped, right? Being stamped. What if it's not possible to stamp? It didn't say what happened if it's. Oh, we just do. Wait, what? What if it's not possible? Say return empty. Is that what it is? What if it's not possible to stamp? So D. What if it's like this? It's not possible to stamp. I think we broke it. We didn't break it. So if it's not possible to stamp, then we return empty. Okay? It is guaranteed. Any answer specifying more than this will not be accepted. Yeah, so, okay. So we basically have to, So the stamp, this is a continuous, right? So we apply continuous into this. And we can only do it 10 times. 10 times the length, right? 10 times the length. So, what's the strategy? Like each time we stamp, right, we need to know what letters is getting stamped, right? So I want to use this as an example, just to draw draw on the paper and see how that one goes. So we have A, B, C, A, and the stamp is A, B, C, A, right? All right, so it's like this. If hold on, doesn't it always work? If I just do a 10 times target length, because it says 10 times target length, if I given a stamp, I can just do like moving window, right? We do these four, no, like here. We do these four, and then we do these, oh my god. We do these four, right? And then we do these four, and then we do these four. So the total number of steps would definitely be shorter than the length of the target. Will be the length of the target minus the length of stamp, right? So well, here we have 1, 2, 3, 4, 5, 6, 7. 7 minus 4, that's 3. So we do actually 4 times, I think. 1, 2, 3, 4, no, 4 times. So it's length minus stamp length plus 1, the total times. And that's definitely smaller than 10 times target length. So we can always just do that. So now the question is turning into whether the stamp is sufficient to create the original string. That's it. So that's the problem. The problem is not to find the sequence, because it could be any other sequence. Right? It all works. So the question is whether it's possible. So as we doing moving window, right? Every time we do the moving window, if we do the moving window, so any letter that fits shall stay, right? Is that what it means? Each turn you place a stamp over a sequence, replace every letter in the sequence with the corresponding letter. Oh, you're replacing it. Oh, you're replacing it. So that's no. You're replacing it. All right, so this, okay, it's different. I was thinking something wrong. So you're replacing everything. So what the given is all question marks, right? The given is all question marks. So every time we apply it, and it's going to be there. So the strategy that you just thought about is not going to work. Okay, so after we apply it, then we compare to the original string and to see to see if there's any matching. So I'm thinking about here, if I just start from the beginning, right? And then we compare the two, we find out that, hold on. That is not going to work. So only thing is we have to match at the beginning, right? We need to match at the beginning. Yeah, we want to match at the beginning. So we're going to see, we start with A, and we have an A, so we said we can match the beginning. And then we start A, so we're like the longest matching. So we have AA matching, and AB does not match, right? So if AA is matching, but AB is not matching, so we say, okay, we can do A by itself. And the next one, we try to check again. We say A and A matching, B, B matching, C, C matching, AA matching. So next one, we can do the entire thing. And the last one is CA. Ooh, then CA, it does not match. It matched the bottom. So that strategy is not working. And we can go backwards, right? We go backwards. So we match CA and not matching, so we get CA out. And then we try to match if CA is matching, and then Oh, it's also not work. CA is matching. So we need to match CA and match A. So front and back is all matching, and then match the center. Huh. Okay. I still need more practice on this. Right? So we do a front match because when you match eventually, right, you have to do a front. Like if the front doesn't match, then it's impossible to match because it has to be contained within, right? You have to be contained within. So you have to do this to get a front, and you have to do this to get a back. There's no other way to get the first and the last letter. So if the first and last letter is different from the stamp's first and last letter, and it's impossible, we cannot match. So that could be a check, could be an easy check. And then after you match the front and back, so you have to do front and back no matter what, right? You have to do front and back. That's why it says it's 1, right? No, that's actually not. So we can do front and back. I'm trying to see this one. If we do front and back, so we do front, we got AB, right? And then we have mismatch. So from the third, 0, 1, 2, 0, 1, 2, from the second one, we have mismatch. And then when we do the back, we have we have all match, ABC, so that's it. So 0 and 2, right? So we match the front and we match the back. When this one is the same, we can match the front. So we do a 0, which we just get A, and then we don't match anything. And then we do the back, which means we have 0, 1, 2, 3. We have to do a 3, so we have 0, 3, right? So we get a CA, and then we have the middle. Middle is 1, so 0, 3, 1. This one's 0, 3, 1. All right, so now if we have longer, it doesn't matter. It's going to be a recursion because we match the front, we match the back, and then we have a remaining string, right? So this is remaining after we match the front and match the back. Now, in order to match this, since you already matched the front, so we don't want to mess up with the front. So this we shall match with the front again, right? So this is like a new string to match, to stamp. Let's change my word to stamp. This should be the new string to stamp because we already stamped the front and stamped the back, and these do not match when I stamp the front. That means this can only be matched if I stamp with the starting thing. So that is a recursion problem. And whenever we find a case where the match does not happen, we're going to return. That's false. Okay. Hope this is the solution. I have been doing very poorly. Performance is very, very poorly for the past, I think, 2 days. So hopefully today is going to be a change. Today will, I will no longer call it a revenge. It's just to get myself out of the slump, a ridiculously long slump that I have been in. This just feels like, a sport, right? You have sometimes feeling good, sometimes feeling bad. All right. So what we're talking about is we are going to call this thing again, and this one will return to us index, right? Yeah, I mean the strategy is front, back, front, back, front, back. So what we're gonna do, we're gonna define a helper. So I think it will be like this, right? And then helper will be ij will be the start and end. Start and end coordinate, and this one will return a actually we don't need to, we just need to return true or false because we know how it's going to be, right? So we just need to, this tells us which part of the string we're going to match the front or match the back. And once it is matchable, then we know the answer when it returns. We know it. Okay, so now we have this and we have the stamp, right? Now we're going to check. We're going to check from the start, right? So we're going to say for k in range I to, we're going to do a len stamp. So we're going to say n equals len stamp. Okay, so k going to equal to I plus n, right? Yes, so I plus n. And we say, no, I don't like this. I like to say k equals I. And while k smaller than I plus n, then we do while k this and target k is equal to stamp. That should be k minus I, right? If that's equal, then we say k increment. And then at the end, let's say p and q. Yeah, we're going to do p and q instead of, let's say p and q. So this is a p, right? So at the end, we have it. How do we know that if it breaks at the beginning? So it has to match in the front, right? Yeah. So the one returning shall be, so when it fails, right? So we p increment, and then it fails and coming out, which means that's the point where we fail. So if the point of fail is the start, and that's bad, right? So when I say if p equals I, which means p has not moved, we're going to return false, which means we cannot match the front. Similarly, q is going to equal the back, which is j. So q is equal to j, and we're going to say while q is larger or equal to what? To j minus n. Let's see if that makes sense. Just use an example. Use an example for this. So 0, 1, 2, 3, 4. Right. 4 minus 3 is 1. 0, 1. I actually don't think it should be larger than this. Because if I have j is 0, 1, 2, 3, 4. J is 4. N is 3. 4 minus 3 is 1. But if I want to go back, I want to go to here, 0, 1, 2. So it has to be larger. Yep. And target q is equal to stamp. Stamp what? Stamp is going to be q what's the stamp going to be? Q minus j, okay? Q minus j, right? Q minus j and start is 0, but we want to be, and then q will be decrement. So q will be smaller and smaller, and j doesn't change, which is good. Q will be smaller, but the front has to be minus 1, right? So initially it will be minus 1, yeah. So this one, and then we say q is minus equal 1, right? And then coming out, if q does not change, which means that first, at the beginning, it does not match. So we say if it does not change, then return false. Now, if they all change, and we have found the new P and Q, then we're going to have a result. So we're going to have a res. The res, we're going to append the res.append. do I have like extend? Yeah, extend going to be iterable. So when extend what? Extend. So at the front is going to be I, right? We matched on I, and at the back will be j minus n. I think it's plus 1. J minus n plus 1. For example, here it's going to be j is 0, 1, 2, 3, 4 minus n. N is 3, that's 1, plus 1 is 2. Yeah. So we do this, and oh, I think we don't have. This is a tail recursion, which means we can turn this into regular iteration. Yeah, I think this can be. Yeah, I think this can be turned into. What is the termination? What is the terminating position requirement? So to terminate, right? So terminate. So like terminating for this one, this well, mismatch is here, and this mismatch is here, right? So I and j cross over, right? And here, this one's here, and this one is here, and we do it again. So this one will go all the way down here, and this one will go all the way down here. All right, and then yeah, they just cross. So whenever they cross, then we end. Is that what you're trying to say? If it cross, yeah, I think if it cross. So I think this one we can say I equals ij equals 0 and len target minus 1. And this will be while I smaller than j. What if they're equal? Could they be equal? Well, so with both ends, that signifies if they're equal, that means, what does that mean? That means the mismatch and that mismatch happened on the same place. Will that happen? That we say the mismatch is here, right? And then from the back end coming forward. So eventually, I and j happen that they will. Yeah, if it can match. Now, if it can match, I think there's a one more condition, right? One more condition is at the end. So I think I can draw up another situation. Let's just do ABC, right? And then we enter AC. So we say the front is going to be A, and the back is going to be BC, right? Like AAC BC, right? If we do AAC BC, then we say A, BC, and then we do AB, C, CB, A, and then yeah, that one I think shall be a no. Let's try it. I'm thinking about the ending. So AACBC. I think this one is not possible. Yeah, this one's not possible. So if it's possible, after we shed the front and back, the remaining has to be larger than this, right? If it's smaller than this, then we're really not doing anything. Which means, yeah, has to be smaller. Well, it doesn't really matter. We're going to check anyway. So, first condition, we're going to say if j minus I, right? J minus I, plus 1, that's the remaining in the center, like 0, 1, 2, yeah. If this is smaller than n, right? If it's smaller than n, then we're going to return this. It's like failure. If will only work if it's larger or equal to, and we say elif j minus I plus 1 equal to n. All right, equal to n. Equal to n equal to n and equal to n, we're going to say return res if target from j to I plus 1, no, I to j plus 1, I to j plus 1 equals stamp, right? Else, okay? Now it's larger. Then we're gonna run our algorithm. We're gonna do this, find, and then we can exit here. What we do here, we're gonna exit here, and then we're gonna extend the rest, and after that, we're gonna update our j, our item j. So we're gonna say I equals p and j equals q. Right, wait, we move in. Actually, let's put this on the outside. All right, so we're gonna say while is larger while this is larger than n, we do all this, right? Which means in the middle is larger than n, and then we'll hit a point where it's equal, right? When it's equal or smaller, then we're gonna check here. We're gonna say if it is this, and then we say else. We're gonna return, which means it's equal, and then yeah, we put the like return at the end, and we don't have to do else. Say check for success. All right, let's try it. So we have a few test cases. For example, we have ABC. This is the one we come up with. This one should be this, and we have ABC, and this one is ABC. This one will go for 0 and 2, and then we have ABCA and ABCACA, and this one we're gonna go for. So what we're gonna go for this one is going to be 0, 3, and 1. Oh, we did not add return res plus I, right? Res plus I, yeah. Hold on. There are a few things, right? So this is matching the middle. And how about this one? I is here, P is here, and Q matching everything. Q goes here, right? So yeah, if we match everything, Q goes here. So when I come out, so J is gonna be here. I is gonna be here. So J minus I is negative plus 1. The terminating situation is a little bit tricky to think about. So, all right, this might not happen all the time. This might not happen all the time. Let's think in this situation, right? We have, so this, it just cross over. It cross over because J is going to be here and I is going to be here. So I and J cross over. In this case, I is here, J is here, right? So we match I comes here, and J comes here. But then it's hard to identify. Let's see. Oh, it's not very straightforward. So we have the I after we match the front, right? And we have a J after we match the back. And then there are like different situations. For instance, we have these two cross over already after the match. Like after the match, we have them cross over. And like before the match, we check. Like this one, before the match, we check that there are more distance in between, right? And then after the match, they cross over. I think that probably means that they have covered everything. Hold on. Is that true? Seems like, I think this is the right way to think about, but like for this one, after the first match, we're going to be here. After the right match, we're going to be here, and then in between, there's just last. That's one situation that it's not going to match, and now we have another situation. So one situation is when there are fewer letters in between for us to match. Another situation is there are exactly the same number for us to match, right? And the third situation is there are more for us to match, which is actually the beginning, right? So this we know, this we also know. Now what we're worried about is just the generic one. So the generic one, after we're done, of course there is another one, which is after we're done, they cross over, right? They cross over. Now the crossover, because we have already eliminated this situation, and we eliminated this situation, so the crossover must happen when the initial one is larger than our stamp. And so that crossover, if it's larger than us, and then they cross over, that means that we have a match, right? Does that mean we have a match? Because if the initial length is longer than me, and then we cross over, no, not really, because we cross over, it has to probably need to analyze that. Crossover, that means we have, say, like what has been matched to the front, we can know. So 0, 1, 2, say we're going to end at 2, right? And the back, we're going to end at 1, right? So that's the crossover. That means we matched 2 at the front, and we matched 3 at the bottom. All right, so we can calculate how many we matched. So the front match and a rear match, we can calculate it, and then we can see how many is left unmatched. All right? Yes, that seems to be a better way of identify how many has been left unmatched. Right? In this case, We matched the front, we matched 1, matched them back, we matched, yeah, see, this is 0. J minus 1, j minus I plus 1 is equal to 0 in this case, because j is here, I is here, so this be 0, right? So it means we completely match. And this will give us 2, which is we don't match. So this is a match. How about this one? So we're here, so we're going to be here, 0, 1, and then we're going to be here. So when we match this, j is going to be here. Now I is going to be here, and j is going to be here. We basically match it twice, right? Now when that happens, it's okay. So now we have 3 situations. One is we have equal, so the remaining unmatched is equal to the length of the stem, right? And then we have to have a full match. If we don't have a full match, then we say it cannot be matched. It cannot be stemmed. Or if it's a smaller, then we say it's a no match. And if it's a 0, then we say it is a match. So let's just do this. Let's just do while true. It will be easier for us to identify, right? So while true, check if j minus I plus 1 is equal to 0, then we return. That means like after previous match, we're coming here, and then we say we're going to return return res, right? It means there's no more unmatch. And then we say if j minus I plus 1 is smaller than n, then we say we return this. This cannot match. Now we also say if j minus I plus 1 is equal to n, this, we're gonna return this, right? Because it could match or could not match. So if this, then we say it can match, otherwise we say it cannot match. After we've done all this, then we start. This means like it's larger than n, right? It means it's larger than n. So larger than n, so we try on the p side, and if it is a mismatch, we say no. If we're trying on the q side, mismatch, we say no. We'll extend both, we update these two, and then we call it a day. Okay, so I feel like this one has a better chance. So we're gonna go stamp and the target. And this one's going to be moves to stamp. Stamp and target. Alright, let's try it. We passed all these, but I want to try a few more test cases just to make sure. So what we're going to try is like a single letter. This shall be a failure. Oh, that's too easy to fail. Like this. I think we have an issue here. I think we have an issue here. Oh, we don't. We do not have an issue. It's just oh, it's 44. Oh, that's good, right? So what if we add like this? How are you gonna do with that? My answer is 0 and 2. Oh, yeah, that works, right? That works. How about 3? Oh, we find an error. Yep, these are the edge case. So what we have A and A, like 4 A's. This will give us, I just don't know what this is going to give us. What this will give us. And then we have AA and AAAA. This one gives us 0 and 2. This one I get 0, 3, 1, 2. Makes sense. Alright, this one, AAA and AAAA. This one shall give us 0 and 1, right? If we do A, shall give us 0 and 1. Yeah, 0 and 1. But we fail on this one. Okay, so and also this shall give us a 0. That's a good test case. Right, this shall give us 0. And I think this one shall be right. Yeah, this one shall be right. Okay, so why did this one fail, right? Fail on this one. A. So n is 3, right? So we're going to start from the beginning. So I is going to be here. P is going to be here. Q is going to be here. So initially, they already. So next round, it turns into here. Nice. So in this case, we match all the way. And we match all the way as well. So I think the issue, oh my god, what is the issue in this one? So we match from the start, and then we match all 3, and then we have 1 that's unmatched, and then we go reverse, and then we match everything as well. So we go front, we match all these, right? And then we say, okay, we match all this. The next one unmatched will be here. And then we go reverse, and then say we unmatched is here. So I think this should be an analysis in this case. So if I match has crossed the center, right? If I enter the if the match in the front has entered, right? The match from the front has entered the territory of the backwards match. That should be a different consideration, right? That should be a different consideration, because what we're doing is the front and the back. Yeah, I think that is a separate case. So what we have handled here, right? This is like a perfect match, like a good match. But actually, this I think is it's just a special case. This is a special case of this, or you can say this is a special case of this. Okay, we know this is true, right? This is true. If the remaining is the same, then because we're just one pass. Actually, if the remaining is less than 2 times the step, right? If the remaining is more than 2 times the step, then no problem. We can do so. There's no overlap of the stamp. There's no overlap of stamp. But if the remaining becomes like 2 times the stamp, if the remaining is the 2 times the stamp, that's still fine, right? That's still fine. What is the problem is when the remaining is if the remaining is more than 2 times the stamp, we can just keep going until we hit remaining is, if remaining is 2 times the stamp, that's also fine. All right, we can match the front, we match from the front, we match from the back, and if they don't match, and then we keep going. So the remaining is, if the remaining is smaller than 2 times the stamp. All right, say our stamp is 3, and the remaining is 5. Then when we match front and back, we have overlap, right? And when we have overlap, we need to analyze the overlap part. So we need to see, right? We need to see whether they cross over. whether they cross over. If they do not cross over, the P and Q, if P and Q do not cross over, then we still fine. If P and Q do not cross over, which just means when we cross over, that's when we have to pay attention, right? P and Q, if they cross over, and the only time that they're going to cross over is when the is when the length is smaller than 2 times, right? That's 2 times the length of the stem. That's when they're going to cross over. But before that, they're not going to cross over. All right? If we have 2 times, then the maximum chance is they will cross over. 2 times they will cross over. So it's larger than 2 times, then they will not cross over. And also we know that it cannot terminate. So probably what we need to do is we just separate into 2 parts, right? Separate into 2 parts. If it's like larger than 2 times, then we just keep going, keep going. If it's smaller than smaller or equal to 2 times, then we're gonna check. We check what? We check on the remaining, right? We check on the remaining. Not only we check on the remaining, so we know they overlap, right? We know they overlap. So we know they overlap. So we want to know how many of the front has been matched, right? And how many from the back has been matched. Come back to this example. So we have A, B, A, B, C, right? And then we have A, B, C come in front. So we know we got 2 matched, and then the third one doesn't match. And then we're coming back, we know all 3 has been matched, right? So in total, right? So we say in the front we matched 2, in the back, from the front we matched 2, and from back we match 3. And then in total that's 5. Then we say we're good, right? And yeah, I'll probably just count how many that we have matched. And in this case, I'm looking at this case still, right? When I say from the front, I match 3, and from the back, I match 3 as well. But then we have overlap, right? We have overlap in the middle. How do we handle the overlap in the middle? The overlap. Like we match a certain number from the front and we match a certain number from the back. That's when we have an issue. Yeah, if the amount we match from the front and the amount from the match from the back is equal to 0, then we're good. Equal to the kernel length, then we're good. We just return it, it's fine. It's only when we overlapping on the matching. So this is not overlapping. So this one does not overlap in the matching. And this one does not overlap. This one actually does overlap on the matching because one is completely matching, the other is completely matching. So this is actually the same case as this case and as this case. They overlap on the match. This does not overlap. Now this one does not overlap. This one does not overlap. Okay. So our problem is to handle when they have overlap in the matching. When we have overlap in the matching, so we know from where we fail to match, right? So that's the P from the front, and we also have the Q, we know from where we fail to match. And to determine, so which means we need to, so the overlapping part, right? The overlapping part. If the overlapping part is equal in both, then that's a match. If the overlapping part is not equal, if the overlapping part is not equal, then it's not a match. We cannot match it. Because the overlapping part, if it's not equal, right? If it's a difference, if we have a difference, the overlapping part will have a difference, then if we keep doing this, then we're gonna affect the part that we have matched already, right? So the overlapping part, if it failed to match, which is basically what we're saying is in this case, right? We have front match this, and back match is this. Well, actually, front match we match into here. That's here. Back match is matching here. This is the other situation where it's smaller. Yeah, the remaining is smaller. Yeah, the remaining is smaller. Okay, the remaining is smaller is another case. It is another case. The remaining is smaller is a case, and the remaining is smaller. We say no, and the remaining is 0, which is just this, right? We say good, and the remaining is the same. Actually, the remaining is the same, or it's fine. So we just do it, right? After we do it and we check, for this one's actually the remaining. We have crossed over, so maybe we should check for crossed over, right? So when they do not cross over, and then we have this situation, and this situation. 3 situations when they do not cross. Actually, this one should be belonging to the other. So we have actually only 2 situations. When is just it's smaller. Right? If they do not cross over, it's small. And this is actually crossing over, right? So it's when they do not cross over into smaller, then we say it's not gonna work. So if it's longer, and if it's longer, then we need to check if they no. Let's see if we keep matching, right? We keep matching. We try to match this. Yeah, I think we should we match, and we match, and then we remaining, right? This is the remaining. This mismatch. But in this case, we match, and then we match, and we overlap, right? We overlap, and we can actually keep matching this, right? We match, and we match, but we know that this one cannot happen. Like even if we match and match, cannot happen. So that could be a check, right? That is definitely a check, right? That's a check. I think this is a check. I think this is a check. I think these 3 check is good, right? These 3 check is good, and then we need like another check. Right? Another check is for they cross over, right? They cross over, yeah. The first time they cross over, and then when they cross over, we need to check. So we can say when you cross over, if the crossover, the overlapping part is not the same, then we say it's not going to be a match. But what if, if it's the same, then we say it is a match. But what if it is not the same, right? If it's not the same, which means the back, right? The back of the stamp is different from the front of the stamp. And then if we try to match this overlapping part next, so we match from the front, a match from the back, and then they're not gonna match, right? Because the front part, like it matched to the back, and it matched the back, it matched the front to a certain part, and then we match from the back to the certain part in the middle, and then we have an overlapping, right? And if the overlapping is not the same in the two stems, right? If the overlapping is not the same in the two stems, then we say the mat, it's not gonna happen, because if we're moving on, right? If we move on to that part, then we're going to extend beyond. Yeah, because we say we have a mismatch at the back, which means the back, we're going to stamp it, and then we stamp it, and then we say this part must be the same as this part if the overlapping part is not the same, right? If I'm going forward, the overlapping part, and then going backwards, if the two are not the same, and then we cannot reconcile. Let's try it. Let's try this idea, see if it works. So we have overlapping now. We still do this. We still think this one is a valid case. This is like they just this one has no overlapping, right? This is no overlapping, and we can hold this one. This is no overlapping on the matching, like just right, and this actually can be considered as the overlapping match. So we're gonna do this, and then we're gonna say, right, if this is no overlapping, right? So after the match, there's no overlap, and then we have another situation is if j minus I plus 1 is smaller than 0, right? Which means we have an overlapping issue. Then we have overlapping issue, and then we can check which is true for this situation as well. We have overlapping issue. So like this one can be here, this one can be here. So we have overlapping issue. So if this were to this, else if j minus 1 plus 1, j minus I plus 1 is smaller than 0, that means we have overlapping issue. Right, we have overlapping issue. And smaller than 0, we have overlapping issue. Actually, we can still do this. No, we can still do this. Plus 1 is larger than 0, but smaller than n. This one will return this. Yeah, this is not enough for us to match. So we don't even have to go into the overlapping issue. Right. So now we in the overlapping issue. How do we handle the overlapping issue? We're gonna say we're gonna find the overlapping part. So the overlapping part will be from but this is matching, right? So they already matched. So they match from the front. So I think if they even match, so if I have a string, we match my stamp, right, going from the front. So these will match the stamp going from the front. And they also match when I'm coming backwards, right, coming backwards. Shouldn't this mean that it's a good thing? Like it's good? Like if they overlap, am I overthinking this? So this will be the start, right? And then we're gonna match backwards, right? Backwards something. So C, B, A, and then we say these and these because they match the same thing. They match the same thing. So yeah. So if overlap, then we're good, right? And we don't have to consider this. It's just good. If it's smaller than 0, then we just say it's good. Right? Yeah, then if it's smaller than 0, which means we can just do smaller or equal to 0, then it's good. Then return res. Right? I think that should be good. And then we're just gonna check, right? When we extend, we need to check. We don't want we want them to be not the same. All right, so we're gonna say res dot append I, and we say if I not equal to j minus n plus 1, and then res dot append j minus n plus 1 as well. Right, it'd be like this. Okay, run it. Now we pass everything. Okay, so we have just a slight change in here. Let's try it. Submit it. Let's see. Hey, I got a wrong answer. I feel like we're falling back to yesterday again. Let's see. CABBB should be 210. Our output is nothing. How's that? Okay, let's try it. CABBB, right? So we match from front, we get here, and we match from the back, CAB, and we end up here. So this gives us plus 1 is 1. We end up in here. Are we trying to do it again? We match the front and match them back, and then we get this, right? We get only one letter. So that's the scheme that this scheme is not going to work. We cannot match front and back, and then try to continue matching. Match it again. B, and then we'll be putting it here, and matching again, and then we'll match. Okay, so what he's saying is we can do from two sides coming in. Like if two sides coming in doesn't work, so like for each one of them, we can do two sides coming in, or think about it again. Think about it again. We have to match the front, and we have to match the back, right? But it is possible that we do not match the front and the back at the same time. Like we can match back first. Like in this case, just keep matching back. Yeah, in this case, just keeping matching back. Or we can keep matching front. Or isn't that the case, right? We either, yeah, I think that's the case. So for a target, we either match front and back, or we only match back, or we only match front, right? That's one. So for each one, we can do 3. So we're branching out three times, and we'll try to find which one works. Now we're talking about a very different thing. Yeah. Or we just like branch out, match front, and yeah. So each time we just match front or match back, match front or match back. So we branch out. It's like branch out, match front or match back, and then see which one will actually hit. So what we're saying, what we're saying is when a def helper, right, I and j, and when return a boolean value, right, and then every time we pass in I and j, and what we say, let's see how many do we pass. We pass about half. So ij is boolean value. Ij is just the string, right? The string we need to match. So for everyone, we can match front or we can match back, right? And then eventually, if it is a match, what's going to happen when we have a match? So let's see this one. We can say we match front, and then we have ABC, and then we next time match front, and then we match. We match back, match CBA, and then we match back, does not match, but one of the branch succeeds, right? And yeah, this seems yeah, this seems to be So we have a front and back. Right now we match it, and then the remaining, if the remaining is like j is smaller than I, that means we have matched the whole thing. So this one we match front, get here, and then we match front again, get here, match back. We cannot match. So match a front, and then the next one we can match a back. We'll match a front, and then boom, we're done. So we match a front. Then how about this? We match a front, and then doesn't match. We match a back, doesn't match. How do we handle this if you are thinking about it this way? Well, if it's this one, we match a front, and then we have this. We have only one left, and we say we cannot match. And we'll match a back, we say we cannot match. And then this one will be unmatchable, but it is stampable. We match a front. Or are you saying we only match? How do we handle this situation? Because I'm thinking about using recursion, right? Using recursion every time we either match front or we match back. And we match only one of them, and then then you're still then if I match front and I will match all of them, or we can match only one of them. Then we are talking about a lot of different situations. Right? We're talking about match 1, or we want to match 2, or we want to match 3. Depending on how many we have. We have a lot. We have 1,000. Do we only match one of them? We cannot match one of them. This is just given this, can I stamp it? Well, or every time when I try to either stamp front, stamp back, or stamp front and back. We do 3 different situations. If we do stamp front and back, Try that. Yeah, we try three types. So front and back, we're kind of handling this situation. And then we have a stem front, always stem back, and a stem front and back. So if I stem front and stem back, and a stem front and back are remaining. And this will just stem front, and stem back, and stem front and back. Yeah, stem front. Now we say if I is smaller than j, and we also need to pass. We also need to pass. What do we need to pass? We do a trial. So at the end, we need to pass the result here. So it's going to be like what? Temp. It's going to be a list. Right? If this is smaller than I is larger than j, right? That's when we stamp. Then that's a success, right? If I larger than j, then that's a success. And we say return true. I can actually do rest.append. I'm going to save temp. And then return true, right? If not, then we can always keep going, right? And then we can just say if j minus I, actually it's j minus I plus 1. Yeah, this is, oh my God. We stem front, we stem back, and then I think it's this thing. I think this one still works. If this, we're gonna return true. And the temp, rest.append, temp, right? Temp, and save it. Rest.append, temp, return true. If it's not, we're going to return false, right? Yeah, let's just say in this case, so it's not going to work. Yeah, the remaining length is smaller than. No, it's still going to work. Oh Lord, well, that's not the case. That's not the case. Because if we stamp only one, because we are now talking about we can do two things. We stamp a front or stamp a back, right? We're talking about we stamp both sides or stamp on one side. So all we know is if it's smaller than, so that means we have achieved. And otherwise, we do not. We do not. And then we try stamp in front. We say, we do this, right? So this is to stamp front, p equals I, and then we do this. After we do it, we're going to say temp.append. I'm going to say no, if p is equal to I, p is larger than I, right? then we stamp the front, p is larger than I, then we're gonna, not changing j, right, I'm gonna dot append I, right, we're gonna append I, so we stamp the front, append I, and then we're gonna do helper, p, j, and temp. This is stamp the front, and we're gonna say if it succeeds, then we're gonna return true, right? Else temp dot pop, right? That's stamp the front. And if it's equal, that means it cannot stamp the front. Then we're gonna stamp the back. We stamp back. So this one's gonna be Q. Right, stamp back. I'm gonna do Q. Same thing. And then if this is smaller than Q, Q smaller than J, then we say temp dot append. Append this j minus n plus 1. Right? And then if helper I doesn't change, and Q temp return true. So front stamp just front, stamp just back. If both fail, right? If both fail, and we come in here, and we say stamp front and back, right? But then we have an issue. We might be checking the things that we don't want to check. Oh Lord, this might time out because we might need to memorize. So yeah, we stamp front, and then we stamp back. Yeah, that's the same thing. And we do need to stamp front and back. Hold on. So if we only stamp front, stamp front, and then we stamp back, yeah, we do need to have so ij, right? We need to have ij to give us this is like the first time that they have encountered, right? It's the first time they have encountered I and j, which is successful, and we put it, and then every time else. So otherwise, we just say we're gonna stamp front, stamp back, stamp front and back at the same time, right? So we're gonna say stamp front and back. I'm gonna say if p is larger than I and q is smaller than j, right? So if these are true, so I'm going to stamp front and back. I want to say temp dot append. So we stamp front and then we stamp back. Dot extend, I, right, stamp front, and then we stamp back, and I say I, and j minus n plus 1. So we're going to extend this, and just say if helper p and q, temp, then return true. And then temp.pop. Alright. And And then finally, if all these fail, then we're going to return false. But we definitely need to create a DP. Right, DP is equal to num times n. So range n. Right, so this is the DP. And we don't need this for now. So every time coming in, I'm going to say if dp ij is not none, and return if it is none, right? Then we do all this. If it's not none, like a true or false, then we don't do anything. If it's none, then we do this, and then we say nope. If it's not none, then we return dpij. If it is none, then we try to do this. We're gonna say dpij equals true, and then return. Instead of return here, let's just say else. Put all of these in the else block. Right? Else, now we say stand front, blah blah blah, and then we can do this helper, this, right? No, I don't like this. I don't like this. Return it immediately. So we say it's true, and then we also return true. But we don't have to return, right? We already put in this. So, but this logic is a bit difficult because we want to return immediately, right? We want to return immediately if it's successful. So we do this. If it's successful, I would say dp. That's also ij, right? Ij equals true, and it will also return true. And then this is the same. dpij is true, then return true. And this is also dpij return true, and then here is dpij equals false, and then return false, right? So that's this, and what we're gonna do is we're gonna call helper, right? Helper, I is gonna be 0, and j is going to be n minus 1, right? And temp is just going to be this. We'll call the helper, and after we're calling the helper, we don't have to use, so we're going to just check dpij. Right? We check the rest, right? We're going to return. I'm going to say return res 0 if res, else res. Else just empty. Okay, let's see if this one works. List out of range. Did you not check inj? Wait, how is... the first one is going to even fail. Not even do we have list out of range. P and J. Yeah. So we just make it larger. Okay, make it larger. N plus 1. N plus 1. And we're going to start Oh. N plus 1 is not going to work. No, I think n plus 1 is not going to work. We're just still going to do n and n, and we can check this first, right? We check this first. We do this check first. And then if this one failed, that means I is still smaller than j, so I think they're still within range. Oh, we're still out of it. One problem at a time. One problem at a time. I think the first one we have issue. So we start from the rest is terrible. The rest is 0, 1, 2, 0. How? Let's run the algorithm in our mind. So we have AA, CBC, right? And then we have ABC. That's the stem. So we say the start gonna be 0, 1, 2, 3, 4, 5. No, 0, 1, 2, 3, 4, 0 and 4. 0 and 4 is our starting position, right? And then we pass 0 and 4, and this doesn't pass, and this is also not none. Is none, so we do here, which means when I try to stamp the front. So after we stamp the front, P is going to be 1, right? P is going to be 1, P larger than I, and then temp gonna dot append I. So we're gonna append I, and then we do P is gonna be 1, starting from 1. J is still 4, so 1 to 4. So now 1 to 4, come here again. We haven't done that yet. And then P is currently equal to 1. And we try to stamp again. And oh, we pass again. So we pass. Now we have 2, right? Now we have 2. No, it's 0. We append 0. 0 and 1. So we have 0 and 1. Now we have 2. Right, so we go here again, which is pointing at 2 now. So pointing at 2, I is 2, coming in, and coming out. F fail, right? Fail. So start from the front, failed. And now I'm going to try to go from the back. So now I is 2, J is 4. If we start from the back, boom, boom, boom. We match BC, right? We match BC. Match BC, which means our Q becomes 2, right? Our Q becomes 2, and this is fine. So we are going to append 2 into it, and we go to the next one, what is here. So I is going to be a 2 and 2, right? 2 and 2. 2 and 2 is not none. Actually, 2 and 2, it shall be, yeah, it actually should be considered bad, because we only have 1 left, and we cannot match if it's smaller, right? We cannot match if it's smaller. So it shall return false. But we try it again. Then we match. Ay. So we know that. So we have in this case, we have 5i5, right? And so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and then we only need to consider the diagonal on top, right? We don't have to consider bottom. So all the 0, 0, like for this case, right? All the 0, 0, all like itself, these are all false. Right? It's all F. Diagonal is all F, right? Because there's only one, we have 3. And only all the 2's, right? 0, 1 is going to be false as well. And 0, 1 is going to be false. 1, 2 is going to be false. 2, 3 is going to be false. 3, 4 is going to be false, right? They're all going to be false. Now, what we wanted to know is 0, 4, right? We want to know 0, 4. That's our target. We don't know if 0, 4 is true or false. So if we want to know, say, ACBC, want to know 0, 0, 2, right? From 0 to 2. AAC, right? 0 to 2, because that's 3 letters, right? 3 letters. We know if it, to know this, I mean, 3 letters is surely, it can only have one, because it either match or not match. So 0, 2 is going to be false, right? And then ACB, which is 1, 3, is also false. And then 2, 4 is also going to be false. Now, we want to know 0 to 3, right? 0 to 3. How do we do 0 to 3? We do 0 to 3 by checking any possible matches, like previously. How do we check? Like what type of match are we checking? So it's going to be a 3-step, right? Now we have only 4 letters. So if we want to stamp it, it's going to be overlap, right? So the overlap requires that so there's only like one way, just to stamp front and stamp back, right? And then we check these are all false, so this is going to be false. And we check this ACBC. We're going to stamp front, stamp back. The front is a mismatch, back is a mismatch. I mean, front we have a match. Front we have a match in A, and back we have a match in BC. But in the middle, but how do we use the previous information to achieve here? Well, we actually don't, right? Like every question is okay. Let's try one that's worked, like AB, ABC, right? It's the same thing. We have a 5x5. ABC, right? And then we know the diagonal is false because we can. Should I set it as false? No, it's not false. We need to know like how many can be matched. Like this, we can match in the front. Like this, like AB can be matched. Well, how many can we match? Like if we say it's gonna be, I'm gonna start from like 3 letters, right? Say ABA. How are we gonna match ABA when you say, well, ABA is 0, 3, right? So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So we have 0 and 3. So 0 and 2. 0 and 2. So we have 0 and 2, which is this one. I want to know. So can we know this by looking at, say, 0, 1 and 1, 2? 0, 1 is AB, 1, 2 is BA, right? Actually, we can't, because this one, all we know for ABA is ABA, we match the front two, and front can match. Or let's do like AB. I mean, like if you want to do ABC, what are you going to try? So what you're going to try is here's going to be 0, 4. Can we get it from 0, 3 and 3, 4? Like if 0, 3, we have a match. And then 1, 3, we have a match. And then we see if these two matches. So like 1, 3, we have a match until in 1, 3 we have matches that's ranging from like we just put ABC, ABC, like we put a stamp in all positions and see what can we get. So ABC, ABC, AB. So we only have AB, so we can match until, so we match 0, 1, right? We match 0, 1. That's for the position 0, 3. For 0, 3, we can match to, we have 0, 1 matching. And then for 1, 4, ABC, ABC, we have matching is 1, 3, right? So for this matching is 0, 1, for this matching is 1, 3. So 4, we want to see if the match between these two can combine together. Well, in this case it can, so we say this is a match. This is still an easy case. Let's go back to AACBC. So AACBC, our starting point is, the starting point is 3 letters, right? The starting point is 3 letters. Starting point is 3 letters, which is AAC, right? 1, 2, 3, 4, 0, 1, 2, 3, 4. The 3 letters, we try to find A, B, C. So what we can match for 0, 0, 1, 2, right? 0, 1, 2. What we can match is, we can match 0, right? We can match 0. And we can match 0 and 2. But we cannot match, so we have something like in the middle, we cannot match. But that is not going to be helpful, I guess. If I have something that I cannot match. ACB, what can I can match 1, and that's it. That's the only thing we can match. We can match 1, and CBC we can match 2. 0, 1, 0, 1, 2, 3, 4. Match 3 and 4, right? Now we're looking at AACB. We will try to match AACB. How much can we match? So we're looking at this 0, 3, and 0, 3 we can match 1. So one of the stamp we can get us a match to 1. And another match can give us match 0 and 2. So one is give us 0 and 2, and the others give us 1. But when we match 1, the 2 is going to not be matched anymore. So it has to be like matching from the start and a matching from the back. Yeah, that's exactly matching from the start and matching from the back. But if I have front and back, but have something in the middle that's not matching, that is not going to work. Let's see. Maybe that's not, maybe it doesn't have a substructure to work with. Yeah, I mean, the problem is I don't know how many times, like we do front and back, right? In this, yeah, I'm trying to get back into this. I think dynamic programming, maybe it doesn't work. Because how do you divide, all right? Like A, right? And I have A. How do you divide? And we have overlap, right? This is the overlap issue. And the reason that we fail is because this cannot be approached from both sides. This can only be approached from a single side. But we don't know when to approach from single side, when to approach from both sides. Like we can attack from both sides and then fail, right? And then what? We attack from single side. If we attack from the single side and it fail, so do we like just attack from single side and then try as many as we can, and then we attack from the other side as many as we can until we cannot do anymore, and then the remaining how is that different from attacking from both sides? Well, it is different because attacking from both sides in this case, so we attack from the front, right? We attack from the front. In this case, we attack from the front, and then we fail because the remaining is not enough. And we attack from front and back. The remaining is not good. And then we attack from the back. We have remain. So the next round, we try it again. Attack from front. Not good. Attack from the both sides. No, attack from front. It's no good. Attack from back. It is good, so we can keep working if we attack from the back, right? And then you're saying that each time you just attack from front or you attack from back. But if you attack from front or attack from back, this AAA thing cannot satisfy. AAA and AAAA, right? This test case. How are you going to satisfy this test case? If I attack from front and then I fail, right? Attack from back, I fail as well, and I just call it fail. But this, if I attack from both front and back, and then we have an overlap, then I succeed, right? So that means we just attack from front, and then we have some result, and we fail. That's fine. Attack. We just do attack front and attack back. We just do 2 attacks. So there's like attack from front, and this is the remaining. And then we attack from front again. This is the remaining. And then we attack from front, and then we fail. Right? We fail. Now each time, I can also attack from back, right? And attack from back. This is the remaining, and we fail again, right? And then at this stage, we can also attack from back, and then we remain this when we fail. And then we have this, right? Attack from back. With this, and try it again, and this one, we also fail, right? And then, so this is just attack from front and back, and then we also can do like attack front every time. If like both fails, we also try attack front and attack back. So this attack front and back, and then we try to see if the overlap. So maybe if we change the idea here, so we still do the front or back attack, right? We still do this attack, but we make sure that when we attack, do we still like do DP? Do we have still memorize? I think memorize shall work, right? So attack front, because when we attack back, and then we try to attack front again, does it? So if I attack the front, right, or attack back, that will give us a different thing. But for attack front and the remaining, and then we attack back, compared to attack back and then we attack front. So that is the same, right? That is the same. Yeah, the remaining is the same. How is this different from what I'm trying to build here? Right? Attack from front, attack from back, attack from front, and then we say it's fail, which means the building blocks is going to be like the small case. Like AB, ABC, right? Building block. So AB, ABC, we attack from front. We're going to have ABC left, right? And then ABC succeeds. So we can do attack from front and attack from front again. So we attack front and front, and then that one works. So which means, hold on. The iteration will work if I attack from front. If I attack from front, and for the remaining, it's going to be front and back, front and back, front and back, right? And attack from back, the remaining front and back, front and back, front and back. And if both fail, and then I try attack from front and back, and that still fail, then we say it's going to fail. So let's try this again. So we do not consider overlapping if we only attack from one side, right? Yes, so we're only attacking from one side in this case. And we're going to say if we only attack from one side, So we check for I and j first, right? We're going to say if I and j so we're going to say if they're outside, so like after we attack and then we keep going, right? Or we keep going. After we attack and then we keep going, and it will go outside only when like we attack and it went outside. Like AACBC, right? We should prevent IJ from going outside in the first place, right? In the first place. So we should check every time. Yeah, I think we should have a hot check here. So we're going to say if j minus I plus 1 is this is the remaining, right? And it's smaller than n. This is going to return false immediately. This is going to be dpij is going to be false. Which we can actually set up here. Yeah, we can set up here. If dpij, I set it here, is not none, we're just going to return. If it is none, so this that should be already set here. So I'm going to say for I, right? Nah, that's fine. Let's just, it's okay. Return false. This one is false, right? Elif, if it's like the remaining, right? IJ will be the remaining, and if j is larger than, yeah, j has to be larger than I for this to it. So now if j is smaller than I, right? If j is smaller than I, and this is the case, Elif it's equal to 0, right? Which means we fully match. Then we're gonna append, and then we're gonna say this equals true, right? Else, so this else means it's either larger than n, but it cannot be smaller because we set a case here. And this only happened like we match once, right? Only match one from one side. So when we go in, it's larger. So we match on one side, and if the remaining is smaller, then we immediately can go false, or it goes to 0. I don't think it's gonna go. No, I don't think it's gonna go smaller than 0. Because smaller than 0 is not considered here. So this one guarantees that it's going to be larger than n, right? Larger than n, because whenever we find out larger than n, yeah, it's going to be larger than n. So it's larger than n, right? Now we can go attacking from the front and attacking from the back. So we say we're going to attack from the front, right? We're going to attack from the front. Attack from the front. We do this, and then we say if p is larger than I, then we can attack. So we say temp $append, and we do helper, which is this is attack from the front. And if the helper returns true, then this is going to be true. else, right? Else. If it's false, that means the temp here is not working, so I'm gonna pop it, right? And then whether we do it or not, we're gonna also attack from the back. So this is attack from back, right? Then we say if this is gonna be true, and else, which means we fail, then we pop, right? So this is we finished attack from front, and then we finish attack from back. Now, when we finish attacking from front, attacking from back, I'm going to go here, right? So attack from front. But if it's true, then we don't have to keep attacking anymore, right? So like if attack from front, we succeeds, then we don't have to attack from the back again. Yeah, we should return here. So we say if this, and then return false. Yeah, we just return, immediate return. Every time we get it, we return. Here's the same, we immediately return true. Now we don't have to wait, right? And then here, the same thing, immediately return true because we don't want to wait. No point in waiting, right? So attack from front, attack from the back. If none of them work, then you need to attack from both sides, right? Yeah, that's an attack from both sides because we have P and Q already, so we know where they're going to land from both sides. So we say if we attack from both sides, yeah, and if this, right, and we're going to say P, Q minus P plus 1 is smaller or equal to 0, right? And that means we have a result. That means res dot append. That means we can do this. Because they overlap, right? They overlap. That means we go here and we go here, and then they overlap. Now, when they overlap, I think we can do it twice. I think that's fine. They overlap. We just do both. That's fine. Right? I and J. We start from I. The other one we start from J minus N. So that they could be the same, right? So yeah, let's just do this. Like we say temp dot append I, and then if I not equal to J minus N plus 1, and then we say temp dot append J minus N plus 1, right? So we do this, fix temp, and then this one we're going to append the temp, and we're going to say dpij is true, and also going to return true. And if this does not satisfy, then we say dpij is going to be false, and then we return false. Okay, let's try see if this one works. Okay, first one pass. List, okay, so still the list out of the range is still an issue. Okay, so why? Here. What happened? So ij coming in is right? And then ABC we attack from front, so we're gonna end up here, right? End up here, 0 and 2. So I'm passing 2 in, 2 to the end. No, so 2 to the end is no, so we try the front, right? Try the front, and looks like we need to check these first. Right, I'm going to check these first, and then we say this. Ha! It's still out of range. No matter how I change it, it's always out of range. Oh, I think it's because here is out of range. Yeah, we do this is equal to 0, and return true. So they equal to 0. Yeah, I and j equal to 0 there already, so we never do it here. We never do it here. And then we also don't need to do it here. So we don't do in these two places. And then this one will pass. So we don't do it these two places. These two just checking, right? And then, okay, so let's try everything else. Okay, we have 0, 1, 2. 3 is failing. Oh, but it's fine. We should probably just sort it. Yeah, let's just sort it. Yeah, let's just sort it, because they say you can return anything. So we should say sorted this equals sorted answer. And then, all right, let's try this one. See if this one gives any good luck. Okay, run it. Oh, this one's passing. Just to double check. Okay, try it. Pending. Judging. Oh, we have wrong answer again. So what is this one? This is a new one that we fail. Supposed to be expected. My God, let's do every single time, huh? Um, 3, 2, 0, 5, 1, 4. Actually, it has to be, no, I cannot do sorted. I think the order matters. The order matters. But for this one, it doesn't really matter. I think 0, 1, 2, 3 is fine. But this one, the issue is more severe. I say 0, 1, 2, 3. Wait, the first stamp is here. BB. Let's see. Should be any one of these shall work. Huh. Hold on. If it's this, it's this, right? And then we say if it's not none, we can return this. Otherwise, we try this, right? And then if it fails, then we try this. If it fails, then we try from both sides. Let's try F, F, F. E, F, F, E, B, B, B. So my idea is we're going to try the front, F, F, so we're going to have this, or we try from the back, we're going to have this, right? So we're going to try from the front. Now we have F, E, F, F, E, B, B, B. Now we try from the front again, 1F, so it's this. Now if we try from the back, we have BB, so we left this. Now we try from the front again, so E, F, F, E, B, B, B. And that one is no good, front is no good. Right, front is no good, so we can only try from the back. From the back, it's going to be BB. So it's going to be like this. Right, next one is EFFEB. We're going to try from the back. Front is no good. Back is no good. And front, back, both no good. And both no match. And then, oh wait, this one actually does match one. It match a B, so it come out EFFE. And then we bad. So this is bad. Which tells us if this is bad, alright, we'll return false. So in here, we know this one is bad as well. If we tried front, no work. We're going to try back, no work. So we say this one is bad, right? So this one is also bad. So we say this one's bad. Then we come in here. Now we can go FE, FFEB, right? And this one coming from front is going to give us this. And this we already checked. This is going to be bad. Coming from back, going to give us FEFFE, which is going to be bad as well. And then we go from both sides, it's going to be bad. So this is going to be bad. So this is going to be bad. So in front's back, bad is bad. So this one's all bad. Which means going from front, it's going to give us bad. So we have to go from the back. I think FFEBB. I think the problem is every time you're doing it, you try as much as you can. I think the thing is you should peel off only one letter in this case, right? If you peel off only one letter, like we do F, we peel it off, and then we have FFE, FFE, BB, we peel off one, and then we do FFE, and then FFEBB, right? Which means we just do 0. We do 0. We do whatever the end is. FFEBB 0, 1, 2, 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4, 5. Yeah, so we do 0, we do 5, which is peeling the front and back, and then we do front. Yeah, we do front again. But this time we're gonna do all three. We're gonna pick all three. Ah, man, we pick all three. And then the remaining is good. How are we talking about how many, like if it's, so do we still go from front and back, but then we have to decide if we do it once or twice, because if I'm repeating, right, if my stamp has repeating, then I can match individual ones, right? I can either match all of them, or match one letter, match two letters, right? We can decide how many we want to match. So like in this case, we can decide if we want to match one F or match two Fs, right? If we match two Fs and the remaining is here, and then in the back we can also decide whether we want to match one or want to match two. If we want to match two, the remaining is FE, FFE, B, right? And then we only can match one, and then the remaining is unmatchable, right? It's a fail. Or we can say we match only once. I'll match only once, match once. We have FFE, FFE, BB, right? And then we have FFE to match, right? I have a better chance, right? So we can say, well, I want to match one, right? And then we have, but if this is just, how do we determine how many to match at the front, how many to match at the back? And if we match like one at a time, that's gonna be a lot. Like when you recursion to a doesn't feel like the right solution to me. Or do we 0, 1, 2, 3? We match here F, F, E, B. Why even we do that? Doesn't make any sense. And match it 10 times. The target length moves. The target length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at most 100 moves, right? So 100 different matches at most. If we match so like for this, we know that at least we need to do, yeah, this is 5. So we need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I need like 2, right? And say 2 is not working. 3. That's another thought, right? So 2 stems not gonna work. How about 3 stems, 4 stems, 5 stems, all the way? Because the maximum, it says 1,000, so it's 10,000 times. So each time, like, what about 3 stems? Well, 3 stems, how do you know that 3 stems works or doesn't work? Well, 3 stems, if it works, three stems, I can do, if I want to cover the entire thing, so we always have to do the front and back, right? There's no escape, because we need to get the front and back. They have to be stamped no matter what. Even in this case, right? Even in this case, we're stamping front and back. So we have to stamp front and we have to stamp back. It's every single one of them. Otherwise, we won't reach the end. We won't reach the front, right? So we have to do front and back. And if the back is not good, then it's not going to be good. So we do front and back, and that's 2 steps, right? At least 2 steps. Right? At least 2 steps. We do front and then we do back, 2 steps. And then we see how the result looks like. So for this case, right, if we do front and back, we're going to have FFEBB and FFEBB. And then the target is FFFE, FFE, BBB. So we compare the two, and we identify is the front and the back. Oh, actually front we match 2, back we match 2. Right, so with front we match 2, and then with back we match also 2, right? But if we do this, then it's not going to be matched because the next one, it doesn't match, right? It doesn't match. So it cannot be. So right, we stamp front, we stamp back, right? Next one. So after we stamp front, all right, let's say this is the target, and this after we stamp the front. This is after we stamp the back, right? And that's to match. So let's say we stamp front and stamp back just in order to match the first letter, right? First letter. So we peel off the first letter. So for the remaining, and then we want to match the front and I want to match the back. So we stamp again, right? So we'll stamp again. So the target is FFE, FFE, BB, and we stamp again, FFE, BB, and B, B, F, F, BBE, F, F, right? And depending on which one we use first, and then the middle can be interchangeable. So now we compare, right? We compare why at this time you do multiple. Well, this time we do multiple because we overlap, right? Because we overlap. That's why we do multiple. Like if we do not overlap, so why do we peel off only one? Because it does not overlap, right? So first two attempt, we do not overlap, and we just remove front, and then now we overlapping. The ideal is we'll have to do front and back, right? This is absolutely necessary. We have to do front and back because we need to reach front and back, right? Now after we reach front and back, the front and back is the only chance that we can reach them. Now the second letter from the front, we have two chances to reach. One is the first stamp, and the other is the one position, right? That's two chances. We have two chances. So as we go in the middle, there are more and more chances that we can do to make changes. Which means, right? Which means the first letter can only be achieved by the first stamp. The second letter can be achieved by the second stamp, the second position of stamp, or the first position of the stamp. And the third letter can be achieved by the third of the stamp, or the second stamp, or the first stamp, right? So it's like this. So we check the first stamp, we check the first letter, and we realize, oh, it can only be reached by the first stamp. And if it cannot, then we just escape. If it can, then we look at the second letter, right? And the second letter can achieve by the first stamp, it can, or the second stamp. So let's say what? Like it's good. It can achieve by the first or the second, right? And that's good. And the third letter can be achieved by the first, second, or third. Now we see it cannot be achieved by the third, which means this F can only be achieved through either the first stamp or and achieved by the second stamp, by the stamp at position 1 or position 2. So now we have restrictions, right? So for F, 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 E, F, F, E, B, 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 and our stamp is F, F, E, B, B. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the first position, it can be only achieved by stamp at 0. For the second, we can be achieved by stamp at 0 or 1. The third one, right? The third one can be achieved by stamping 0. No, we cannot achieve by stamping 0, but we can be achieved by stamping at 1, right? Stamping at a 1 position, or stamping at 2 position. E can be achieved by only by stamping. Like for E, we can achieve by stamping at the 0 position. No, we cannot do 1 position. Yes, can achieve by 1 position. How about at 2 position? No, 2 position. Oh yes, 3 position. It's no good, right? So it can only be achieved by this. Now we look at next one, number 4, right? 4. Again, we 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. It cannot be achieved by stamping 0, right? Stamping 0 here. It cannot be achieved by stamping 1. F, F, E, B. No, it cannot be achieved by stamping at 2. But it can be achieved by stamping at 3, right? So this can be achieved by stamping 3 or stamping at 4. That's how this one can be achieved. Now 5. For 5, we cannot stamping on 0, but stamping on 1, no good. Stamping on 2, no good. Stamping on 3, no good. Stamping on 4, stamping on 4 or 5. So that's 4 or 5. Now, next one, again, has to start stamping 1, 2, 3, 4, 5. That's stamping 2, that's no good. Stamping 3, no good. 4, no good. No, what are you doing? Stamping 4 is good. Stamping on. Okay, so E, right? E, I can stamping on 0, no good. 1, no good. 2, F, F, E, 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 B, B, no. Stamping on 3, 3, it'd be F, F, E, B, no. Stamping 4, stamping on 4, F, F, E, so we can stamping on 4, right? Now, number this, can stamping on 3, F, F, E, B, B, yeah, stamping on 3 is good. Stamping 4, F, F, E, B, yeah, 4 is good. Stamping on 5, F, F, E, no. And the 6 is no good, 7 is no good, okay? So this one, stamping at 4, right? Stamping on 4, F, F, E, B, B, that's good. Stamping on 5, F, F, E, B, B, that's good. 4, 5 is good. 6 is no good, right? And then the last one, 9, stamping at 5, F, F, E, B, B, 5 is good. 6, F, F, E, B, 6 is good. And then no good. Okay, so now we have a list of which one is good. So we have first F is 0, second F is 0 or 1, third F is 1 or 2, the E is only 1, and then F is 3 or 4, and then F is 4 or 5, and then E is 4, and then B is 3 or 4, and then another B is 4 or 5, and the last B is 5 or 6. So these are the only positions that if we stamp, we can cover the letter. So based on this, we need to analyze. So we find out the ones that we can only have one stamp that can satisfy. So E, the first E we have to stamp at 1, and the second E we have to stamp at 4. So 1 and 4, right? 1 and 4 is a necessity. And also the front and back, right? Front and back. How is the last one achievable at 5? F, F, E, B, B. F, F, E, B. No, last one is only 5. It cannot be 6. Yeah, last one is 5. And then the first F, the last B, right? These are, so 0, 1, 4, 5 is what we need. And then we check if we do 0, 1, 4, 5, how many others can be covered. So we do 0, 1, 4, 5. The second one can be covered. The third one can be covered. And this F can be covered because we have 4. This F can be covered. This will have 4. We can be covered. And this can be covered. So 0, 1, 4, 5 is sufficient. Right? So if we do 0, 1, 4, 5, so 0 will be F, F, E, B, B, 1, F, F, E, B, B, 4, 0, 1, 2, 3, 0, 1, 2, 3, 4. Then change it to F, F, E, B, B, and 5. 0, 1, 2, 3, 4, 5. F, F, E, B, B. Don't get F, 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 E, F, F. That is not correct. We might have made a mistake. Let's try again. This is the new solution, right? F, F, E, B, B. That's a 0. Right? And then we say 1. So it's F, F, E, B, B. And then we'll say 4. 0, 1, 2, 3, 4. F, F, E, B, B. 5, 0, 1, 2, 3, 4, 5. That becomes F, F, E, B, B. Yeah, it is not correct. I think there's an order. There's an order. The order is so 0, 1, 4, 5. So if we do 0, we can cover the first two. And then we do 1, we can cover FFE, right? And then if we do 4, we can cover F, F, E, B, B. We do 4, we can cover all of these. And then we do 5. So we have to do 5 first, and then do 4. So it has to be 0, 1, 5, 4 instead of 4, 5. Right? If we do 0, 1, 5, 4. Which technically we should do 0, 5. We always do 0, 5. So it is actually like in order to avoid, so we always do front and back, front and back. So let's just try 0, 5 and 1, 4. Right? If it's 0, 5, 1, 4, so we have F, F, E, B, B, and then F, F, E, B, B. That's 0, 1, 2, 3, 4, right? 5. So that's 0, 5, 1, F, 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 E, B, B, right? And then we do 4, 0, 1, 2, 3, 4, F, F, E, B, B. Yep. F, 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 E, F, F, E, B, B, B. So that works. Let's try something else. Let's try A, B, A, B, C, right? So we have A, B, A, B, C. And our stamp is A, B, C. So to get A, we have to stamp at 0. To get C, we have to stamp at 0, 1, 2. We have to stamp at 2, right? Now, to get B, we can stamp at 0. And that's it. To get this A, we have to stamp at 0 is no work, A, B, C no work, A, B, C, no work. A, so we have to stamp at A. 0, 1, 2, we have to stamp at 2. To get B, we have to stamp 1, like A, B, C. No, stamp at 2. A, B, C, yeah, we have stamp at 2. And then we cannot stamp at 3. And now we have 0 and 2, right? So we pick the unique. A has to be 0, so we can pick unique at 0 and 2, and then look, oh, B covered, oh, A covered, oh, B covered, so 0 and 2. All right, let's try another one, A, B, C, A. Let's try this one. We have A, B, C, A, C, A, right? And our stamp is A, B, C, A. First one, 0, last one is 0, 1, 2, 3. We have to stamp at 3, right? So that's the 2 stamps we're going to consider. So the second A, we can only stamp at 0. Yeah, we can stamp at 0. No, stamp at 1. Stamp at 0 is not going to work. Stamp at 1 is going to work. Stamp at 3, no, we cannot stamp at 3, it's not covered. Now, consider B. Stamp at 0 is not going to work. Stamp at 1. That's A, B. Oh, stamp at 1 can work. Stamp at 3. 0, 1, 2, stamp at 2. No, it's not going to work. That's it. Now the C, we're going to stamp at 0. A, B, C, A. No work. Stamp at 1. A, B, C. Yep, 1 is working. Then stamp at 2. A, B. No. Stamp at 3. A. No, not going to work. This A, we're going to stamp at, we cannot do 0, we have to stamp as 1. A, B, C, A. Yep, stamp at 1 work. Stamp at 2. A, B, C. No, stamp at 3. Stamp at 2. 0, 1, 2. Stamp at 3. A, B. No, stamp at 3. 0, 1, 2, 3. A, B. No, stamp at 4. A. So it's 1 and 4. Right? No, there's no 4. Maximum is 3. So that's going to be 1. The last one, C, we stamp at 1. No, cannot be 1. It has to be 0, 1, 2, 3. We start with 3. No, we start at 2. A, B, C, A. Not going to work. Start at 3. A, B, C, A. Yep, start at 3. It's going to work. So this is what we have. So uniquely, first one, so always first one is 0 and 3. We pick the front and back. And then we're going to see what else? The second one is going to be 1. Right, I'm gonna hear 1. Right, it's like find the unique in the front. Right, how do we do? We find the unique. So the front and back we need to check. After front and back check, and then we just move like this. Front and back check, and then we move in. This one is unique. Then we put it in. This one is 3. We're already in it, so we don't have to worry. All right, we already have it. If not, we're gonna do it. And then keep going in. 1, we already do it. And this we already have it. This we already have it. So this one 0, 3, 1. How about these? How about A, and now we give an A. So front gonna be 0, back gonna be 0. Now front gonna be 0, back gonna be 0, 1, 2, 3, back gonna be 3. And then to match this one gonna be 1, to match this one gonna be 2, and then front back gonna be 0, 3, 1, 2. Alright? 0, 3, 1, 2. Okay, that works. How about AA? Front is 0, back is actually 2. Right? Front is 0, back is 2. 0, 1, 2. And then second one is going to be we can do 0 or we can do 1. Right? And then the third one we can do 0, 1. We can do 1 or 2. Right? So we go front and back, 0 and 2, and then 0 covered, 2 covered, so we say that's 0 and 2. How about triple A's? Triple A's, front is also 0, back is going to be 1. So front is 0, back is 1. And then in the middle, second one, we can do 0, we can do 1, we can do 0, we can do 1, right? And third one, we can do 0, 1, 2. So 0, 1, 0 covered, covered, so we're good. I think this might be the solution. How about CABB, right? I'll have CAB. Front cover has to be 0, back cover has to be 0, 1, right? 1. So we have 0 and 1 coming out. And then second A has to be covered in 0 because 1 doesn't work. This B has to be covered in 0 because 1 doesn't work. 1 CAB, or yeah, 2 1 doesn't work, 0 1 doesn't work. And then 0 covered, covered, then we're good. It's 0 and 1. All right, let's try this solution. It's completely different from this. All right, so our suggestion is for we're gonna do what, like a set, all possible. We're gonna put in there, and it could be, you know, like a set, right? Each one's going to be a set, and then let's come back to this. I want to find like a really, so we have 0, 0 and 5. For this one is 0 and 5, and 0 cover. And this one we can do 1 or 2, right? But we don't want to try, so we have to actually go through it and go through like when we go through everything. How do we pick? We go from front and back, right? We have to go through everything and pick out the ones that's pick out the ones that's unique, and then what? And then we need to decide what else to put in, right? We'll pick out the thing that's unique. So front and back, we'll definitely put there, and then we also need to pick out other things that's unique. Yeah, because they gotta be something that's, if it's not unique, what's gonna happen if it's not unique? Then we just need to, yeah, what's gonna happen if you're a thing that's not unique? Well, front and back is definitely gonna take care of itself. So we're gonna say, like, coming from the front, we have 0, right? And next one is 0. The next one we can do 1 or 2. So we're gonna say pick 1 or 2. And then could be 1, could be 2. So 0 is needed. So now we have 1 or 2. So first position, so 0 is needed. And then we have 1 and 2. Right? And then 1 and 2. And then we try to pick. So from front is 0. Done. Now we go from the back. 5. 4, 5. Covered. Then take 5. Right? And then there's 5. Oh, nothing. So we're done. So we are at this level. Right. Now I'm going to start from the front again. We have 1, 2. Right. Next one is 1. So this becomes 1. The next one is 3, 4. So nothing can we pick. So we put 1 in here. And then we're gonna end it here. Now we're going from backwards up. So B is 3, 4. Right? Going back up. B comes to 4. Back up. 4 is good. backup 4 is good, and then we end. So now we put 4 in there. Okay, I think this might work. So we first construct the entire thing. Each one is going to be a set, right? And we're gonna say, how do we do this? Target. Right, so for each letter of the target, so we're gonna say possible. It's gonna be a list, right? And then we're gonna say for lettering target, right? And then for each letter, we're gonna try stamp it. Right, we're gonna try stamp it. How do we stamp it? We're gonna say temp gonna be a set, right? Be a set, and then I'm gonna say at my current position, so it'll be I this, and enumerate target, right? So we can be stamping. The stamping range is from the stamping range. So going to be from my I, so I minus n, right? Minus n. So if it's 0, 1, 2, 3, minus n plus 1. That's the stamping range. That's the stamping range on front. It's actually going to be max, this and 0, the stamping range in front. And the stamping range from the back is going to be like not from the back, it's like the furthest, and it's going to be myself, I, right? I, and I plus n, right? I plus n. So if I say here, because 0, 1, like 1 plus 3 is 4, 0, 1, 2, 3, so it's going to be minus 1. That's the back, right? And then n minus 1. No, not n minus 1, n minus 1, right? So it's going to be the min of these two. So that's the stamping range. I'm going to say for j in range this, right? This is our stamping range. Now as we go through this, it could be j minus I think, right? J is going to be 0, 0, because we need to go inside here. So this is the stamping range, right? But what I want to know is from here, stamp here, stamp here. So stamp on this, stamp on this, stamp on this, and stamp on this. That's actually not correct. Stamping range, this is right, from 0 or this. And then the back range is actually not correct. The back range shall be like the most I can get. It shall be I, right? It shall be I, right? I, and it shall be I, which is myself, like I am the stamping, right? Or it's actually going to be n minus n, right? So if it's this, if it's 1, 2, 3, 4, 5, 5 minus 3 is 2, 0, 1, 2, right? That's the position. So yeah, the position is n minus n. N minus n, 0, 1, 2. That's the, and then we're going to take the minimum of this, right? So that's the stamping range. That's the stamping. We can stamp here, here, here. So as I stamp, right? As I stamp, I need to know which position in the stamp is actually matching to me, right? I need to know which position in the stamp is matching to myself. So if I stamp from 0, and I am at 0, I'm stamping like here, I'm stamping from 0, and I have an I, right? So it should be the stamping range, right? It's going to be the stamping. So this is the stamping start, right? This is the leftmost in the stamping. So it should be j minus I. That is, oh, should I say I minus j? I think it's I minus j. I minus j is where it is in the stamp, right? Do we have to do any other things about it? No, I don't think so. It's just I minus j. I minus j is the position in a stamp. So we're going to say if stamp I minus j is equal to letter, that means j is good. So dot add j. We can put j. We can stamp at position j to acquire letter. And after we go through everything, we're going to say position dot append temp, do a copy, right? So after we go through everything, right? After we go through everything, now we have a good thing, a good thing. So I'm going to go through a loop now. So I'm going to go through the front until we cannot do anymore. So we're going to have a while true on the outside. So we're going to say start from front. Start from front, right? How do we start from front? We're going to pick each one in a position. Actually, yeah, I want to have like an I and J again. So let's say a P and Q. So P equals 0, P, Q equals 0, and len. Len position is going to equal to target. So it's going to be n minus 1, right? So start from front. And we just say P, right? And we say while true again. I'm going to figure it out later. So we're going to say current, right? Current F equals to possibilities. Possibilities going to be P, all right? This is a set, right? I'm going to say while true. And then we're going to say, what do we say? We say this F equals current F, current, I shouldn't say current F, let's just say new F current stamp. Right, I'm going to say new stamp equals current stamp dot intersection position P. Right. This is going to return the same thing as still position P. So it's the same thing. And we say if not new stamp, like if it's empty, so are you sure that it's gonna end up like in 1? Oh yeah, it's gonna be a 1 because we start with 1. So if not new stamp, so new stamp is empty, which means we have entered the new, if not, then we're going to say result. Okay, result equals this. Then that means our current stamp has to put in, right? Our current stamp has to put in. So we say res.append current stamp. What if our current stamp is 2? No, it's not going to happen because the start is 1, right? 1, 1, 1 until we fail. And then if it's 2, it's 2. That means we can stamp 1 or stamp 2. Like we can do like 2 positions in a stamp. Alright, so here like we can stamp at 1 or stamp at 2. It doesn't matter. And then this one will matter. If it still doesn't matter, then that means stamp at 1 or stamp at 2 is fine. Anyway, we go all the way to the end, right? We go all the way to the end. And do we append the current stamp, like a set? If not new stamp, which means it's the position P is no good, and then we're gonna append current stamp. Now, current stamp could be a single one, or it could be a double one. And what if my current is a double, and then I try to append a double? Like if my current is a double, and I encounter one which is no good. So like I'm saying I can use this, I'll use this to achieve myself, but the next one, to achieve the next letter, it does not overlap with me. So I can do this or this to achieve, but the next one does not overlap with me. If the next one does not overlap with me, that means it doesn't matter. We can just pick one, right? So we can just say .append list current stamp 0. We just get the current value, and that's fine. If not new stamp, right? And yeah, this is new stamp, so we have this. Basically, we end here. If not new stamp, we end here, and I'm gonna break. Otherwise, P gonna increment, right? P gonna increment. And once we've done this, and then we also gonna say start from back, and we say same thing. Current stamp is going to be position Q. And say while true, new stamp equals current stamp dot intersection position Q, possibility Q, and if not new stamp on the res, and then it's going to be Q minus equal 1. So we get it back as well until the current stamp dot intersection, the new stamp, does not work anymore. Now we come out with a new stamp, and then we just get 1 in there. Alright, so I want to see what will happen if we fail, like this one. We fail. Alright, we have ABC as stamp, and we have A, C, B, C. So the first one we can stamp at 0, the last one we stamp at 0, 1, 2, right? Second one we stamp at 1, because 0 doesn't work, we stamp at 1, and then we cannot stamp at 3. Let's see if this will work. Minimum, so 0, 1, right? 1, or yeah, so stamp at 1, and then C will be stamping a 0. 1, 2 doesn't work. B, we're gonna stamp at a 0, doesn't work. 1 doesn't work. 2, and stamp at 2. Stamp at 2. So this is what we get, right? And then we say, I'm gonna pick a front to 0, and the next one, boom, not working. I'll pick 2, right? Doesn't working. 2, 2 doesn't work. So now we end it here, and now we this first round we end on this, and now what we see is we're gonna go with 1, right? And then go 1 doesn't work, and then last one we're gonna go 0. So this is the result 0, 2, 1, 0. So we 0 has repeats. Does that mean if we have repeats, that means it's not gonna work? Is that how we're supposed to do? So what does it mean that we have repeats? That means as we go from the front, we're trying to figure out what we need to stamp, right? It's incompatible, right? This is what it means, right? So it's incompatible as we go, right? Should be the same one, same one, same one, same one, and then yeah. So it has to be like a stretch of them will be satisfied by one stamp, right? A stretch of them have to be satisfied with one stamp, and then a stretch of them will be satisfied with another stamp. And then they overlap or no overlap, doesn't matter. So they have to have common stamp that will satisfy certain ones. So in this case, what we have is now we have common stamp for 1, and we have front is 0, and then we have one of them that doesn't satisfy. Like it's just sticking out, right? Now how do we consider it sticking out? It's because this thing, this 1, does not get used by anybody else. Right? So we say this 1, and then we put in another 1, and that does not get used. See, like if the first one we say is 0, and the second one we say we can only allow 1, right? At the stamp at 1. And then the third one we say only allow 0. Right, so these are unique. These are uniques. So we say we need a unique 0, and then we need 1, and we need 0 again. So uniques, right, shall be shareable. If the uniques are not shareable, like I am unique, I only can do 1, and you are unique, and you can only do another 1, and we cannot share. I mean, yeah, it's fine because they do not share either, right? But the uniques cannot be, like if we, like the unique and the unique cannot have something in the middle, which does mean like in the final result, we cannot have the same value repeats. The same value repeats, right? If we say we stamp here, stamp at 0, stamp at 2, and then we stamp at 1, right? And then we say we're going to stamp at 0 again. And then that means we are going to cancel whatever we have done already. So I think I'll use that just to see if it works. And also see if this one works. So this is going to be, so that's going to be +1, -1, and then, so we can be if, well, P is smaller or equal to Q, right? And we do this. And we just pick one of them. If both works, that means it doesn't matter which one we pick. And if not, new stamp, and then we do this, otherwise we'll break. We just keep doing intersection, intersection, going from back, intersection, intersection. It's the same thing. And once we're done, we're gonna have a result. And then we're gonna say, unique. Say if len res equals len res equals len. Let's say set res, which means there's nothing, we're going to return res, right? Else we're going to return empty. Oh yeah, that's wrong. That's a copy. Yeah, this 0513 is fine. I think this one's fine. 0513 is fine because we do 0513. We have index out of range. Okay, so 012. Okay, this one we have issue with our solution. Let's print. We tried this and this one it doesn't work. Oh, did we like add something twice? Let's see. We have pause. Yeah, 013. Print bus 0311. So 0 and then 3 and then we go 1. We need to do a check. So we go front. If we already reached the back, then we don't do anything. So we're going to say here, start from back. I'm going to say if front of P is larger than Q, right? So, and then it's null, and it'll be here. If P is larger than Q, and then we just break. Yeah, P larger than Q, then we break. Okay. So, and then these two still pass. How about the rest? We still have index on the range. 0, 1, 2, 0, 1, 2, 3. Oh, that's fine. That's fine. 0, 3, 1, 2. That's fine. So we have 6. 0, 1, 2, 3, 4, 5, 6. Okay, so this could be like a special case. Let's just see what's going to happen. Oh, I don't think it's going to print out. It's just going to say timeout. Not timeout. So what do we say? Probably let's print the position here. Just want to see how it looks like. Print pause. 0, 0, 0. Right? They're all 0. And then we're going to start from here. While P is smaller than n minus 1. P is smaller than n. Right? And this is while Q is larger or equal to 0. Right? Then position is correct. Blah, blah, blah. Then if not new stamp, then if we get out, let me say else, right? Else is if we get out from here, P smaller than n, and then boom, 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 we never hit it. And that means we are going to do this, right? Because it means that everything is good. Everything is good. So we just append this. And then we say if this, and also we're going to do the same thing here, right? If we go from back, all the way to the front. Oh, it's not larger than, it's going to be smaller than Q, right? While P is smaller than Q. P is incrementing, right? P is incrementing. And then has to be smaller or equal to Q, right? P is smaller or equal to Q, and then we do all this. And then if this is already getting out, which means P already covered everything, and then actually we can break here, right? And then starting from the back, the same thing. If Q is larger or equal to P, right? And else, and then we can break as well. And then this one will pass. And let's try the rest. Number 7. Oh, that's fine. So 0, 2, 1, 0, or 0, 2, 1. That's fine. 0, 2, 1. I think it works, right? 0, 2, 0, 1, 2, CAB, 1, 0, 1, CAB. Actually, it's not right. We have an issue with CAB. I think we did CAB earlier, and then we say it's fine. How is... Shouldn't be... God. CABBB. How is this not working? Result, we get 0, 2, 1. 2. Because we have CAB, right? CAB 0, 1. Where is 2 come from? What the heck? Where did 2 come from? Didn't make any sense. I have a 2. How? How? Come on, man. That's not right. The last one should be 1 instead of 2. It cannot be 2. CAB, if you do 2, we go outside. So it's something wrong here, right? I said minimum, so J is going to be maximum. So we are at what? We are at 0, 1, 2, 3. We are at 3. So it's going to be 3 minus 3. So it's going to be 1, right? 1 to minus 3. N is 5. All right, 5 minus 5 min will be, so either from myself going forward or from 5 minus 3. No, that's 1, 2, 3, 4. CAB. Oh, CABBB. CABBB. Oh, shoot. CABBB. Ugh, CABBB. Oh, CABBB is going to be an issue. So this B gonna go 1, right? CAB, right? And this B, CAB. 2. Yes, we do have. And then from going from the front, oh shoot, this one cannot be going from front. So we know the first 3 is going to be 0, but we cannot go from front. This one has to go from back. Oh my god. Yeah, so like this B has to go from 1, and the last B has to go from 2. And we cannot just do 0 and 2. Like 0 has to be the last one to be there. Unbelievable. Like what? Do we... I don't know, man. This is... Are we gonna fail 2 times in a row? So 3 hours and 15 minutes. And I still have no clue, zero clue at all how to proceed. And I changed from so many different ways and it still doesn't work. Yeah, in this case, CABBB, we cannot go from front. It has to go from back. It's like it has to go from back. If I go from back, how do I know which way to go? How do I know I need to go from back instead of go from front? Oh man. To each turn. So we know we cannot do like all the way from front. Just like can do all the way from back. How does that come to pass? Alright, so sharing, right? So we know we have some sharing, and then we also know we have some non-sharing. So we know that if we do 0, right? We do 0, we're gonna affect CAB. We do 1, we're gonna affect this B. Then we do 2, we're gonna affect this B, right? So we need to put them together, and we see. So it's gonna be like this. It's gonna be like this, right? Like this has to be this way. Okay, let's try something else. Let's try the FFF stuff. So we know first F, right? 1, 2, 3, 4, 5. And that's the FFEBB, right? FFEBB. So we don't care about this. Second one have to be F, right? So first second is this, and then is going to be 1. So we're going to be F. F and E, right? F and E. F and E. And 1 F, F, E, B, B, right? And then the third one is, I don't know, it'll be 4. 4, 4, now it's going to be 4. All 4, so it's going to be 4. So front 0, 1, 2, 3, 4. F, E, B, B, right? 4. And last one gonna be 5, which means F, F, E, B, B. So that's this, right? Come out as this. So we need to like overlap them. What we know is like which one to go first. And this one go first, and then we go this one, because this can overwrite. So we can do this, and then if we do this and then do this, like if we have unknown, which will be overwritten by the thing, that's good. But if we have unknown to override the none thing, right? If this overriding this, then that's bad. So whoever has the unknown shall go first. Right? So in this case, whoever has unknown shall go first. So we're gonna go this first or this first, doesn't matter. Whoever has unknown has to go first. Whoever has none need to go last. Whoever has none need to go last. Which means like the ones with all none values, that the most unknown value shall go first, and the most none values shall go the last. That is the order. So in this case, we can still use this, right? We still use this, but instead of putting in, we need to see, right? We need to see as we go through the P, right? As we go through the P, and we are doing the stamp, right? Like we blah 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 blah, we getting it, and when we get out, we need to see how many we can determine with this stamp. Like how many we can determine with this stamp. So we're gonna say how many we can determine. So it's not gonna be a res. It's gonna be, let's say, power, or the power, right? So the power we're gonna append as the stamp, but we're also gonna append another thing. That's the number that we can do right now. How do we know how many we have done? So you keep incrementing. P is already changed. So we need another value. You can see it's gonna count, right? Count equals 1 because that's this. Actually, no, count is going to be 0 because we're going to do this, right? And then we're going to say count plus equal 1. And then coming back, it's good. Count equals 1. Coming back, and it's no good. So we're going to append a count and a list, right? So we're going to count 2. So we have a count and we have the current stem that we need to use. So that's that. And this one is the same when append these two things. Right? When append these two things. Now we're going to do this, so we're going to reset count. Right? So this and this, a reset count. It's exactly the same thing. Right? We're going to go count plus equal 1. And then we're going to do, this is going to be count. No, it's going to be count. And this is going to be count. It's going to be count. Right? So, there's no rest. It's power. No longer rest. So, this is going to be power. And then, we're going to print power as well. And at the end, we don't even do this. Let's just check out. The power, we say, we're going to sort it, right? We're going to sort the power, so we know the number that we can do. So we know number we can do. This covers 3, this covers 1, and this only covers 1. So we're going to do the ones with the smallest first. So we're going to say, how do we handle? So we're returning different things. We're gonna have this one will be power 0. I'm gonna do 1, and then yeah, I want to check it the same way, right? Check it the same way. So we're gonna 1, gonna cover 1. That's also, if they all cover 1, then everyone cover 1, which is fine, right? Yeah, and if everyone is, now this is covering 2, so covering 2, we're going to do the last. Cover 1, we say we're going to do 0, and then we're going to do 1, and then we're going to do 0 again, so that's the problem. So the rest is going to be, when it's sorted power, right, key equals lambda tuple, it's going to be tuple 0, sort based on this, which means the smallest, right? And then this is going to be stamp for stamp in no. We sorted, and it's still going to be tup for tup in. Sorted this, going to be tup 1, right? It'll be tup 1. Then return the same, and then we pass in this one. Now we sorted, right? We sorted. Let's see how everybody else do. 0, 1, 2, 3, 4, 5. This one doesn't matter. 1 or 0, 0 or 1. Doesn't matter. Okay. Now we pass everything here. Oh, we're gonna check here. Submit. Index out of range. Oh my god. Index out of range. How is index out of range? Oh, this is an error to begin with. Oh, we never had this one before. Like the error to begin with. Okay, that's fine. I'm gonna handle it like a champ. I guess this we cannot do. So, we didn't consider this, right? So we say, oh, it's here. Wait, where? Here. We can get out here as well. So, blah blah blah, and then we say, if not temp, and then directly return. Tuple object is not callable. What? Did you miss a comma? Ah, yes, I did. Yeah, this, I forgot to check here, which is going to be .add before we put it in here. All right, submit, pending, judging. Ooh-wee. This is also wrong. I'm starting to giving up. It's just like, again, second day doesn't work for us. We're approaching 3.5 hours, and we still have no clue how this one can be done. We do a 7, 2, 6, 3, 4. How? We do 7. Okay, we have M, D, A, D, 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 and a 4A, right? So let's see what happened. What happened here? We are going to print out. We're going to print out both things. So we're going to print out the possibilities, and I'm going to print out the power as well. So we have these two. Oh man, this one does look like it's possible. So we have 0, 0, 0. We say 0, 0, 0, and this one has to be 2. And next one has to be 3. Next one 4, 4, 5, 6, 7. is MDA, right? MDA is our stamp. MD 012 MDA. Yeah, so this has to be 2. Here's the issue. If this is 2, like if it's 2, so I think it is also important to notice, right, as we do 7 2 6, like 7 2 6 3 5, and then we do 4, and then we do 0, and then when we do 0, we're eliminating this. So that means the adjacent ones has to share. No, adjacent one doesn't have to share. It's just it has to, or we just when we come out with a solution and we just try it, right? If it doesn't work, that means it's just not working. Would that work? Like we try it and then we just say we're gonna map it and see if it works, right? How do we do that? Stamp. We're gonna actually stamp it, right? How do we stamp it? So we say we're going to stamp it. Yeah, I'm going to stamp it. Let's just stamp it to check, right? So we're going to have a outcome equals list target. And then we have result before r in less, right? And then we're going to say for I letter in stamp outcome r plus I equals letter, right? I'm going to do this. That's on a square again. But it's in stamp. I think depending on how many results we have. We're just going to stamp it. Yeah. And after we stamp it, we're going to say return s if this join outcome equals target, else return this. Enumerate. I'll pass, and we'll pass every single one. And then when if we time out, that's it. Oh, Jesus. 0, 1, 2, 3, 4, 5, 6, 7, 8. What? What? What's the outcome? How? How? I tried it many times. It worked. How is that possible? Okay, we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10. Oh, let me just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. we're going to do 5 and 0. F, F, E, B, B. Do 5. 0, 1, 2, 3, 4. F, F, E, B, B. And I'm going to do 1. F, F, E, B, B. And I'm going to do 3. 0, 1, 2, 3. Oh my god, it is wrong. It is wrong. Should be F, F, E, B. 0, 1, 2, 3. Should be 4. How come it's 3? How come it's 3? Should be 4. How come it's 3? No, that's the problem here. That's not the problem of outcome. It's the problem of... That's not here. It shouldn't be. Let's print pos and print power. Yeah, 3, 4, 4, 4. It's always 4. Zero and 1. How is it 3? Well, actually, in that case, I don't even have to go from both sides. We just keep going, right? Yeah, we just keep going. Just say power, and then just say current stamp equals position P, right? And then say P equals 0. I say while P is smaller than N, right? And count is 0. So while P is smaller than 0, new stamp, right? I'm going to do this, this, and this. New stamp is going to be current stamp dot duration. If there's no new stamp, then we're going to append current stamp. So it's this, and then the current stamp is going to be current stamp is this, new stamp is this. Good. P plus 1 come here. New stamp equals current stamp, and then this. Boom, we're good, right? And then come here is 0, and then the new stamp. The new stamp is empty, right? New stamp is empty, so we can say current stamp is going to be the ones before, and then we append the power, and then once we append the power, we have to count reset, and we need reset a current stamp equals position P, right? And then reset a current stamp, but we do not break, and else, right? Else we're going to say current stamp equals new stamp and P increment. And we don't have to do all these. These are not necessary because we changed the logic. So it's going to be this. Let's try it. That's still not right. That's still not right. Okay, that's actually even more wrong. The power is even more wrong. Because you never increment the zero, the count. And this also has to be count plus equal 1. Okay, that's still not right. Because you never enter this. 0, 1, 1 is going to be 2, 4, 1, 2, 3, 4, 5. 5 of them would be 4. That's true. 4, 4, 4, 4, 4. But the last one, the last one coming up is a new stamp. So it's still 4, right? Then coming up, current stamp, if not. And then, so new stamp. So at the end, I think we need to add a new stamp as well, unless we get out, right? So yeah, so when we get out, we'll have current stamp, new stamp, and then it is, so current stamp equals new stamp, come now, so the current stamp, we need to also do this one more time as we get out, right, as we get out, and then we have a new one, is 5014. Right, if we do 5014, I think it will pass. So 50, we got F, F, E, B, B, F, F, E, B, B. That's 5 and 0. And then we do 1. All right, so 0, 1. So F, F, E, B, B. And then we do 4. 0, 1, 2, 3, 4. F, F, E, B, B. Yeah, I think that's one. That one is correct. Okay, so comment out this. And then we're going to get out all this. That's fine. Number 3 is fine. 0, 1, 2, 3. This one's any order will work. Doesn't really matter. This one, any order will work. Right? But 7, 0, 1, 2, 3, 4, 5, 7. This one, this one, shouldn't that be 0? So you cannot even do 2. How is that? No, that's not the one. 0, 1, 2, 3, 4, 5, 6, 7. Here, this one. The result is empty. Jesus. Jesus, that's truly, truly power. Wait, print, let me see, what's res? Res is 1, 2, 0. Oh shit, 1, 2, 0 does not work, right? C, A, B, 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 B. No, no. Wait, is it C, A, B, B, B or C, A, B, 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 B? Yeah, C, A, B, B, B. So C, A, B, B, B. If I go 1, C, A, B, right, 0, 1. And I go 2, C, A, B. And I go C, A, B. Ugh, we have an A. It has to be 2, 1, 0. Ah. So we need to sort. And what? Sort it and also it's probably gonna fail something else. So we sort it so we know, but what if we what if the amount is the same? Well, if the amount is the same, we're gonna do. Okay, let's check. So we have CAB and then we have CAB and CAB, right? This is the situation. We say the ones with more, so we say we delay this and then we get the other one in first. But if we do this first and then this will cover, right? So we have all these. So what is the order? So like now, I'm a position, right? Not position, a possibility, and the power also provides an information on where or how we should attempt this. And how should we attempt this? Oh, this is CAB. That's just on 3. These nothing. So as we cover 3, cover 1, right? So we need to start with cover 1, but we have both cover 1. If both covers 1, which one shall we go first? I would say the one closer to the end shall go first. Close to which end? Because if we go 1 first and then we will be replaced, it will be replaced, which means we should also know the position, right? And the position more to the extreme shall go first. More to the extreme. This is hard to say. Like how do you determine which one is more extreme? Right? You don't know which one is more extreme. Well, I do know, but what's the logic here? Like in this case, right? I have CAB, I have unknown NNB, and unknown NNB. And CAB, we have 3, right? We have 3 on CAB, and then we have 1 on 1. So priority goes to the 1s. And when the priority goes to the smaller ones, then we're going to keep sorting based on what? Based on the close, based on, so among the ones that has the smallest, they have to be ordered in such a way that they will do the ones that will not be covered by others. And we have the position, so shall we also sort based on position? No, because if we sort based on position, then the other situation will happen where in the front, right? We have to consider in the front. Front and back. How about we just do front and back? Front and back. Once we pick, like, they're on the same level, so we have different levels, right? We have different levels. Like these are on the same level because they shall be implemented first. Like that's true, right? The ones has the least amount of change shall be implemented first, and then when we implement them first, we shall go the we still don't mean a max. That still doesn't work because we cannot go this first. Oh Lord, we cannot go this first. The 1-1 cannot go first. If we do 1-1 first, 1-2 cannot go because 1-2 the 2 is going to change 1. It's going to change 1. basically we need to know which one we go will not be changed by another thing, right? Can we achieve this? Well, we actually can. What if we also set the starting position? So the starting position is 0, and we're going to affect all 3, right? And then this starting position is 1. We're going to only affect 1. And this starting position is 2. We're going to affect 1. That's exactly what this is, right? But we say, so where are we going to affect? The one that's going to be affect. We say this is going to affect 0, 1, 2. It's going to affect 2. It's going to affect, no, 1, 2, 3 is going to affect 3. This is going to affect 4, right? That's this. So that's going to affect 1, 2, 3. That's going to affect 2, 3, 4, right? So we know that. And we say among them, that's actually the ones we want. We try 0, and then we go 1, and then we find out that it's overriding. Then we say no, this order cannot work. So 0 go first. Who go first will not be overwritten, right? That's the question. Who go first will not get overwritten. Well, most likely it's go from both sides. You're not going to get overwritten. So when try 0, and then we try 2, you're not going to get overwritten, and then we go 3, and then 1, 0 get overwritten. So that's not working. How do we not overwrite? So we already identified that the things that has, so the 1 and 2, right? These shall go first. We already identified. So when we identify this, then we need to know exactly which one is being affected, right? Which one is being affected? And we say if we go 1 first and then we go the other one, that will override, right? That means the range, which means the range, right? The range that's not covered by the other one, right? The range that's the longest, has the longest stretch. So shouldn't we consider this as, instead of it's going to be like 2, 3, 4, right? So it's going to be 2 to 4, right? The range is 2 to 4. Range is 1 to 3. Range is 0 to 2. Right? So this is the range, right? The range. And then we're going to sort based on that, and also based on so based on that, we know these two will pop up first. This one will follow. And then if it's the same, then we're going to sort based on range, which means we're going to sort based on maximum on this, or minimum on this. I cannot minimum on this, then it's maximum minimum. So these two actually, it does matter. This has to go first and then go this, right? Because this overrides this. And also because our target is inside here. All right, I'm not doing this anymore. I'm gonna check the answer. I'm gonna admit defeat again. 2 days in a row. My God. And the solution, I guarantee you, is gonna be so simple, so easy. Yeah, if I do 1 first, then I do 2, and then the 2 will cover the 1. It's like I want to make sure that they do not cover each other. How do I make sure they do not cover each other? I don't know. I have no, I don't even have a TLE. This one's even worse than yesterday. I don't even have a TLE. I don't even have a TLE. It's like I already figured out which index to do, but I just don't know how I can do it, like the actual order. It's like if the target, like the target here is going to be 3, right? The target is 3, and this target is 4. And we say 3 is inside, then, right, 3 is inside, so we have to do 4 first. But how do we know which one is inside which? Right, we don't know which one is inside which. And if it's 1, right, and then if this one is another, like say 2, then this one shall go first. So we just do a search, like when we pick out these, and then for each one of them, we look through, right? For each one of them, we see if this one containing another one. If it does, then we say no, you go second. That's not gonna work. That's not gonna work. Huh? No. All right. we're approaching 4 hours and we still have no idea. Alright, we're gonna give up. This is completely debacle. Stamping the sequence. Alright, let's check. I have no idea. I throw everything at it and then nothing is sticking. I start. Work backwards. Work backwards. Moves. Now from the final position, we'll make those moves in reverse order. Ith window, a sub-array of length. Starts at I. Each move of position I is possible if the ith window matches the stamp. First stamp at window 1 to get. Then reverse stamp at window 3. And finally, reverse stamp at undo. I don't understand. I'm reading this doesn't make any sense. I'll read again. From the final position, we make those moves in reverse order. Let's call the ith window. What's a window? Oh, a subarray of target of length that starts at I. Okay, each move at position I is possible if the ith window matches the stamp. That's true. After every character in the window becomes a wildcard that can match any character. If we stamp this, working backwards, we'll reverse stamp at window 1 to get, and then reverse stamp at window 3 to get, or window 0. And, oh, I think I got the idea here. Alright, this is not going to working because it just doesn't work. I'm just going to delete it so I don't have to look at it anymore. So that makes sense, right? That makes sense. Because if it works, then it must exist FFE, FFE, B, B, B. If the last stamp will definitely be, so we must be able to find a sequence, a subarray that matches us. So we just go, what's that we're thinking about? We go the moving window, right? Sliding window, we find the first one, we just find just first one that match. FFE, I'm looking at FFE, FFEBB, right? I'm trying to search for this one. FFEBB. So FFEBB, 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 got it, FFEBB here. So these are the first. So 0, 1, 2, 3, 4. So 4 must be the last one, right? 4. And then these will turn into wildcards, which means they can match anything. The next step, right? We're going to say, again, try to find FFEBB that can match. So we have E, B, B doesn't match. F, F, E. Oh, this match. So we can remove these. So 0, 1. Remove these. And then last one with an F. Okay. I'm going to do 0, remove these. And then keep going. F, F, E, B, B, F, F, E, B, B. Look for the first one. That's, so we have a B here. I have a B here. Okay, so we just do the front, right? And then I want to go backwards. Oh, backwards here. So this is going to be 0, 1, 2, 3, 4, 5, 5, F, F, E, B, so 5. So I'm going to come out with 5, 0, 1, 4. Okay, so how about this one? This one just, Lord, it hit us the hardest. So we do this. 0 is the last one. Coming here. 1. Oh, now we have nothing from the front. I want to go backwards. Right. Actually, we should still going forward. We should always going from forward. I guess not. Let's see. We match anything. All right. So this can be 0, and then done. Going back over again. Then we need to find the first one that's not. Well, we already hit here, so we go from front. Nothing. Nope. We find one, and then we try to see how can we match it. We can match it by CAB, right? Oh, we just still sliding window. Oh, we had a match, so this one can be 1. And then we can do this. Yeah, because here we cannot match. And then slide window, and then we do 2. Okay. And A, C, B, C. This one is like sliding window, we cannot find A, B, C. Then that's not gonna work. And then this one, MDA, D, A. MDA, so 0, this one will match, right? I can find the first match. I have to find the first match and keep going from front. Match here. I have a D, but MDA, so there's no match. Then MDA, no match. So like the remaining, we have no match for the remaining. But I think this idea might time out, actually. Let's see, what is this? Because if we do this, we're gonna do, so first round, right? First round, we're gonna find if it exists. If it exists, we'll push it in. We're gonna keep going to the end. Right? If it exists again, modify it, keep it into the end. And then second round. So first round, second round. If any round that does not find anything, shouldn't that be sufficient? I don't know. So t-list equals list target, right? So I want to make modifications. So what we're gonna say is for while true, for I, range. Everyone have to do this, right? Everything has to compare. So we're talking about ON squared with more. So it's more than this, way more than this. So wait, I think this might time out. This might actually time out. So in range 0 to, actually we're going to do this as well, m equals len step and len target, right, of these two. So for I in range to the n minus n, right? Should we plus 1? 0, 1, 2, 3, 4. Oh, that's 5. 5 minus 3 is 2. 0, 1, 2. Yeah, it's plus 1. Right? So that's that. And then moving window. No, we have to do the first round. If for this and then for j in range for I in here, for j in range n, right? And if target, if t list can be I plus j, right? Equals stamp j. If it's not equal, then we're going to break. Okay, so that means it's not going to work. And then else, which means everything equal. And then we're going to say for else for k in range, and again for j in range, n, I'm going to say t list, t list j, t list I plus j equals it's the wild card. So this is the first round. This is the first round. I'll try to find, right? And then break. And also see found, possible, false, and then else I'm going to say possible equals true, set flag to true, and then when you break out, say if not possible, return this. Now we're going to try to figure out, also we're going to have a less, right? So else we're going to do this and invest.append I, right? This is the position that it's possible. And once we're done, so this basically just, it's a moving window, right? Moving window, and we'll try to see if it's not, now we're gonna get all the stem that we can do. Actually, once we're done it, we should move on. Or should we? Hold up, let's see. Once we find it, return them, and then we keep going, and see if it's possible, right? And which means, right, if it's possible, if I have a stamp, right, and then if we take out from the middle, And if we keep looking at the remaining, we shall be able to match. Yeah, we shall be able to match. If we take out and then we keep going, we shall be able to match, which means it might be possible, right? So we do it one round. Which means we might be able to just hit it here. Alright, so eyeing this range, and then every time when I check, and if it's not good, I keep going, check, keep check, keep check. If it's not equal this, and t list I_j is also not equal to our wildcard, right? If it's a wildcard, we can keep going, and then else we're gonna, which means we have possibility, and then we turn off them into this, and then we're gonna pen so we can do it here, and we keep going until the end, and coming back, I'm gonna do it again. All right. All right, and then we're gonna, so every time we run, we need to see if it's possible. Like if one run, yeah, I'm gonna say possible here. So possible equals false. And then every time we do this, possible is gonna be true, which means at the end we're gonna see if not possible, if one run and then we do not see any change, right? We do not see any change. But here, right, so everything matching, and then we're gonna just turn them again. We need to see also if anything changed. All right. We need to jump, and we don't have to go through the middle again. Right, so we find this, and then we keep going, and then we just increasing the amount of emptiness. Then we go one more time. Hold on. So if we set it into a star, right? So first round we set into a star, and then we keep moving, right? And we keep moving, and then we keep moving, and then we know this is a star, like a star. We have the range for the star. And next one, so we if we next one, do we increase the range for the star? Yeah, I think we can just increase the range for the star, for that increasing the range, right? Increasing the range, and you need to know. Yeah, it has to, right? It has to when we start, and then we go to the end, and we go scan again from the front. But if we scan from the front and say it doesn't work, and then we had this, how do we avoid, right? So every time we scan, we make sure that the end will be all covered, right? So every time we're gonna scan, right? We're gonna scan, we do this, else we do this, right? And then when we finish one round, if it's not possible, right? If we finish one round, it shall get. So which means we start is false, and then it's actually going to be here. It's possible going to be here, right? And then this one, and until we find. So we find one, and we find one. So first round, when we end, we need to make sure that the last is going to be. We need to record. We also need to record when we start. Oh, we know when we start. So okay, so let's just do this, right? So we're gonna go like this. Right, this is the first round. Right, after the first round is done, we're gonna check to see if the last on the T list is a star. If the last T list is not a star, which means in the last one we break out, right? It's not a star. So we're gonna say if the last one is not a star, which means that that's not gonna work. So I'm going to say if the last one, which is T list and -1, is not a star, then we're going to return this. Now we go back. It's actually not T minus -1. It's the current end, right? It's current end. So we're going to say the current end is going to be n-1, right? It's current end. And then we do this. This is going to be the current end, right? The end, n-1 end, -1. Because it's n minus n plus 1, so it has to -2. That's the end position, right? The end position. Now it's going to be end position minus. So 0, 1, 2, 3, 4. The end position is 4, and then we're going to go 3, 4 minus 3 is 1, 0, 1. Yeah, but we want to hit this, so we have to. No, have to go here, so I have to +2. Right? N minus +2. What if I go here? And if our n is here, like this one, right? So when you say this is no good, and then boom, these three, and then our n is going to be put in here. N is here. Well, n is going to be maximum, right? It's going to be maximum this, and maximum this is the actual one, the end position that we can get. So I is going to be 0, right? So we're going to start from front, or we're going to start from, we're going to end. We're going to end at any position. No, we're going to end at any position. So this one, where are we going to end? cannot always end here. It has to be end at a position, right? So the end will be the ones that we haven't checked yet, right? Otherwise, I think we shall be able to check. So we check here, and we shall be able to check this is no good, and then we check this is good, right? After we check, it's going to be like this is the ones not checked. So the end will be here. So we're going to just do from front to, yeah, from front to the end, right? From front to the end. No, no, no. Front to the end. And this is going to be the mean of the two, I think. Right? It's going to be the mean of the two. So because the front is end is going to be the end, and end minus this is going to be the front, right? And eventually, no, this one going to be smaller than 0, so it's going to be the max of the two? No, it's not going to be the max of the two. It's going to be, God, either here or me, right? So the end or this, right? And we can actually go front of the end minus, yeah, that's actually front, which is 0 actually. It is 0. The max of these two, yes, the max of these two, either here or we go 0. No 0, 1. No 1 is 0 is the position plus 1. N minus n plus 1 is the position. It's like the last position we can do, and then we have to range, so at plus 1, right? And then we do the j, and then we see if it's not the same, then we're going to break out, right? We're going to break out of this one, then we keep going until we finish, right? Until we finish, and then we're going to check, right? We're going to check. Where are we going to check? So we have the end is going to be the end position, so we're going to just check on the end, right? Check on the end position, see if it's not, which means after we do it, the end has not been changed. Then we're going to return this. Otherwise, if end is, then we need to just get a new end. Now, how do we get a new end? So we're just going to go from end counting backwards, right? Trying to find the first one that's not. That will be our new end. Can we learn that also from here? So we know we append this, right? This is like every time we do this, we turn everything into star, right? And then, so we're gonna see here. So basically, it's the last one. So we stamp, and we stamp, and we stamp. It's basically the smallest. Yeah, the smallest. So we're gonna go here, and then we're gonna go here, 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 and then this is the smallest, right? So we're gonna say end equals mean less, the smallest in less, the smallest in less, and minus 1. That's our next end. And then I'm gonna return reverse. Let's see. This is giving us trouble. Why is that? Because every while true. It never ends. So end is equal to this. Right, coming back. Eventually, while end is larger than or equal to 0, because if it does match everything, eventually we'll put 0 in, right? And it will be smaller than 0. So this one pass, right? I'm gonna try other solutions. We have some fail, some good. Okay, 0, 1, 2, 3. This one doesn't matter. We can do this, and anything works for this. right? This one, 0, 1, 2, 3, doesn't matter. This one's good. And what else? 4. 0, 1, 2, 3, 4. Doesn't matter. 2, 1, 0, that's all fine. 2, 1, 0 is fine. 2, 1, 0, 1, 2, 2, 1, 0. Yeah, that's fine. Yeah, so we only fail is how do you fail? So you fail, I think I just need to like each round, I want to take a look at T-list, just get a sense. So we got this, right? This is the first round. Second round, why would this one not work? So from range, so we say F, F, E, B, B is not working, right? That's fine. And then we keep going on. Now, which actually at the beginning, we need to also print end. So we're also going to print end. First end is 9, second end is 3. It's 0, 1, 2, 3. Oh, wait, hold on. It's 3. And the range is with 3. So this is wrong, right? We need to have the start be here. So I should be to end. I shall be to end. Yeah, I shall be to end. Then we have this our range. Okay, hold on. I shall be to end, which is fine. And then 3. How is... Oh no, I cannot be end. And I have to be... Oh, it is different. Okay, so it is different. So the first run and the remaining runs are different. So this is the first run. Yeah, we have to separate because the first run we have limitation, and the second run basically we don't have limitation, right? So we say this is the first run. This is the first run. So it's going to be n minus n, right? The first run. After the first run, we're going to acquire n equals min less minus 1, right? And then we're going to do the second run. So this is going to be the second run. So in the second run, it's going to be this, right? I plus 1. And it actually should be the min of n plus 1 and n minus n plus 1. No, this one is not going to be here. N minus n plus 1, right? And then we're going to do this. And then I'm going to check, and after we check, let me see, what is this we need to check here as well, right? Then I'm going to check if this is going to be checked just for n minus 1. Then if it's not, then we return this. Also reset this, and then we just go through. I believe this is actually correct. We can actually run it. I think this is actually correct. Here, and then this and this. Run code. I think this is actually correct. 3, whatever that thing, 3, 2, 0, 5, 1, 4. I think this one, 3, 2. I think this is actually correct, right? 0. Let's do it. Don't guess. 0. F, 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 E. No. F, F, E, B, B. 3. 0, 1, 2, 3. F, F, E, B, B. 2. 0, 1, 2. F, F, E, B, B. Alright, 0, 0, 3, 2, 1. 0, 1. F, 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 E, B, B. Alright, 0, 1, 5, 4, 5. 5. F, F, E, B, B. And then 4. 0, 1, 2, 3, 4. F, F, E, B, B. So I'll get F, 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 E, F, F, E, B, B, B. Okay, let's try all the other ones, see if they all work. So this one, I know it works because that does work. And this one also does work. And then we pass everything. Right? And we pass everything. Okay, let's try this one. My timeout. This one has a long, but I don't think we'll time out. I think we're just gonna have very bad runtime. Oh, I have a wrong answer. Oh, it's not working, huh? Okay, let's see. D D E D D E D D E E. Right? And our guide is DE. So we have DE out 0, 1. E. E. Alright, 2. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this one is 4. And DE 7. Right, that's the first round. And then the E, right, that's the number 8. Second round going from front, our end is going to be, oh, that's why. That's actually, the end is here. The end is wrong. Mm. Mm-hmm. Then we'll run another time. So we're gonna get 0, and then 3, and then 6, right? And then how do we check? How do we check that they have all turned into? So we cannot check. We cannot check. It's here. So which means, all right, I'm gonna add this test case as well. Add this as test case, and then this is going to be, my solution is going to be, I think, 6, 3, 0, 8, 7, 4, 1. That should be the answer. I mean, in my book. So we just need to change here. So we need to say every time the end. No. No. No, 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 no. It's every time when we break, right? Every time when it's a mismatch and we break, that's when we update the end, right? So we're gonna just say end and it equals to 0, right? And then every time, if we keep matching, and then end is 0. Now let's say n is -1, right? N is -1. And then every time we break, end and equal to I, right? No, I plus j. N has to be I plus j, right? N is I plus, so that's the one that doesn't match. And then blah, 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 we get the end. We have an end, right? We have an end. And then here again, right, again, we're going to update end. End going to equal to I plus j. Every time we just, as we keep going, n is larger than or equal to 0, we're going to set so we don't need to set here, right? Coming back up, and is going to equal to the one that's the last is a mismatch. And then coming back up, and is the last that's a mismatch. And back up, then we're going to start by saying terminal max range equals mean and n minus n, and end equals -1. Then this is going to be max range, right? Jesus. 643.210. What the heck? Target is this one. This one is still not right. How? So the first one mismatch, right? Is I plus j. So the first one is a match. The and is here. Right, and is here. And DE we match. Then here this doesn't matter now, and it should be here. Let's just print out end to see where end is. I'm gonna print end is 7. 0, 0, 1, 2, 3, 4, 5, 6. It should be 6. Why is 7? How is end 7? Isn't this the mismatch? One, 3, 4. No, this is not correct. This is not how I imagined it to be. Oh, hold on. So DD, yeah, that's the first mismatch. And then DE, that's 1, 0, 1, 2, 3, 3. And then DD, Oh yeah, it is pointing here because DD, and then DE, I got. So this is like D match, D doesn't match, and D is actually matching to here. So what it should be? It should be first two doesn't match, and then these two match. We'll just walk backwards then. It's just, I think that would be the easiest way. I think instead of thinking about all this, the end, we're just walking backwards. Right? To find the end. Right? And then I'm gonna find it backwards and say for k in range n minus 1, minus 1, minus 1, if k, if t list k not equal to this, then break. Then I say k equals n minus 1, while t list k is not equal to this, is equal to this, then k minus 1, right? And right? So we get end. Then I think I can incorporate this one inside. Let's say end equals n minus 1. Right, so while this, and then we do this, try to find new end. So new end equals old end. Then while new end larger equal to 0, and new end, and then say new end minus equal to 1. Once we're done, I'm going to check the new end. I say if new end actually we don't even need new end. Just put a in. These are just end. Right, I say if end is smaller than 0, then break. Right, I'm going to break. Else, then we can find, and we can do this. Don't have to worry about this. Because the first one is not, so we just go in here, do it again, another thing, 2 rounds, down, and then if this is saying, yo, why 1 appears twice? Seriously, why appears twice? And 4 appears twice. Doesn't make any sense. Alright, let's try print out our t-list. Yes. And then after here, I'll print n. And it's 6. 0, 1, 2, 3, 4, 5, 6. Right? And it's here. And then for 6 or n minus n. N minus n minus this actually is here. I'm gonna go here, right? So and is gonna be here. If j in range n, and then it's gonna be here every time. Oh, that is not right. We have to use a flag. And change equals if it's so we have to make sure that we have a flag so we don't append again. So if it's not the same, then we're gonna break it and go for the next one. If they are the same, or it is empty, then we're gonna go here. Then we're gonna say, once we do this, it's actually here. I'm gonna say change is false. And then for if t-list I plus j is not equal to this, right? And we do this, and then we say change equals true. And then we say if change, then we append. Now we pass. Now we pass this one. I think the maximum we just 2 rounds shall be sufficient. Yeah, now we go back to 0, 1, 5, 4. Now we go back to 0, 1, 5, 4. I think this one works, right? 0, 1, 0, 1, 5, 4 works. 0, 1, 5, 4 works. So this one passed. Now we're going to try it again. Oh. Okay, and then we're going to delete, print. Let's try to do it. 0, 1, 5, 4. Yep. I'm going to submit. Accepted. Oh, yes, finally. But it's nothing to celebrate. 5 hours. 5 hours of work. I think my solution is, I mean, it's not as fast, but it's definitely easier. Like, I don't even want to read what it's trying to do here. Oh man, this is very, very hard. It's probably one of the hardest I've ever done. Like, even the solution is still Greedy and DFS. Greedy. Oh, I don't even want to read. My brain's mushy right now. So I guess I just, yeah, we're gonna settle on our solution and then we're gonna call it a day. Whenever we find a match stem substring, reverse, yeah. Okay, so what should we say in this one? First run, second run. So we only need, I think we only need 2 runs, right? I think so. We only need 2 runs. We only need 2 runs. Like we find. Let's change it. Actually, I don't know. I think we only need 2 runs. So the first run is to identify, and then the second run, we just run it twice. First run, right? And identify this. Now we just run it twice. First run, hold on, don't change anything. Do not change anything. This is our original solution, and we can actually have a solution 2. Right, this is our solution 2, which will just do the same run twice, right? We do first run and second run. Run it twice, so m times n, right? Run it twice. After run it twice, we're gonna check to see, would you say, can we do count? Does it has count? I think it has count. A equals 1, 2, 3. I think A has count. Yeah, A does have count. So we can do tthis dot count. This needs to equal to n. And then we're going to return res. And this one, if, else, empty. Alright, let's try solution 2, see if it works. Yeah, I think. Oh no. No, it does not work. So how many times do we have to run? Wait, why would it not work? Oh, hold on. No, it has to be here. I think it does work. It does work. We're just repeating it. Yeah, the second run is slightly different. First run, no problem. Right. Second run, the else has to change. Second run is going to be like this. Dear Lord. We need 3 runs for this? I guess we do need more runs. I guess we do need more runs, right? Wait, 2 runs is not enough. Hey, 2 runs is not enough. We need more runs. So instead of doing this, we can just say while true. Run however many times we want. Like we don't even care. And then subsequent run. And then we just run it. After we run it, we're gonna check. Cannot check because you need to know the end. Like if 2 runs, okay, be like this. Number of star asta equals this, right? Equals this. And then, well, true, we do this. And then we say, wow. No. I mean, I already passed, but I want to find other solutions. It's fine, it's already 5 hours, so it doesn't really matter. So we say new num asterisk. I think I can actually do star. No, I cannot do star. Equals this, right? And we say if new is equal to old, which is this, then we're going to break. Else, we're going to say this equals new. And then this one is just going to be num this. And we pass. Basically, we just say if the count of this does not change, yeah, subsequent runs. This probably will run a longer time, maybe, I don't know. Yeah, let's see. This one is simpler, easier to understand. We haven't passed this one yet. Here. And then submit. Yep. Yeah, that's fine. So this one, yeah, this is a very hard problem. I couldn't solve it in 4 hours. This is the solution obtained from, this is the official solution. From here. So the official solution is here, so I'll copy this. I didn't use the same algorithm, but the basic idea is the same. We reverse the process. This is like the second time, right? More than the second time that we always reverse it. Like if we go front, yeah, if you go forward and there are too many different options for you to take, so you can go backwards. We reverse the process and do a first run to identify, to find any first run using sliding window. To find any substring in target matches to stem. Any match will be turned into any match position will be turned into a wildcard letter, right? That's what it is. And after the first run, we will check the last letter if it has been converted to wildcard. The run is successful. Otherwise, we directly return empty. Then we perform subsequent run. Then we perform subsequent runs to convert the remaining letter to wildcard. And each time a new convert is encountered, we record the position. No, it's not here. Say if conversion is not possible on any letter, we return this. Each time a convert is encountered, we record the position of the stamp. The result is the reverse. Is the reverse of the stamp. Of the recorded stamps. This one is OMN. OM, where M is the length of stamp and N length of target. I think this one run like 200 something milliseconds. I don't even know, man. Yeah, 208 milliseconds and 51% ranking. But it's poor performance. This one, I think we can probably make it faster by doing this, right? We're gonna check. Just do one more check here. Maybe I can make it faster. Just one more check here, right? Otherwise, I'm gonna count. Can we like? We have a count. We actually don't need to count. We just need to see if. So we're gonna say delta star, right? Delta star. Yeah, we need to say delta star equals 0. Don't need to do this. Just delta star, and then blah blah blah. If then this one delta star plus equal 1, right? Yeah, delta star plus equal 1. We check if it's this. If it's not, now we turn this into this, and now we say delta star is 1. And then we're gonna append. Yeah, that's fine. And then we don't need to count. We just say if delta star equals 0, which means haven't changed, then then you do not know no, we need to know how many stars in total. So we're gonna say num stars equals 0, right? And then every time I think we should do this one as well. So for j in range this equals, but we might overestimate, so it has to be like this, right? And be like this, but we we do not have to say the change because anyone will be appended. So if this, and this num stars an increment, num star gonna increment, right? Num star increment every time, and then at the end we have, this is the first check, and now we have num stars, right? And then we have delta star, and then at the end we're just gonna check every time. We're gonna check, say if delta star is equal to it's actually going to be num stars plus equal to delta stars, right? Delta star, not start, it's star, delta star, right? So num star increment, I'm going to say if num stars equals to n, and we immediately return res, right? We don't have to do anything, we just immediately return. And if not, else, right? If, so num star is not equal to n, and delta star is 0. If delta star is 0, which means we have not increment in the star, right? If that happened, we're gonna return this. So we're gonna not do all this. That's not correct. Why? If it's not equal to n, so we need to keep running. If it's not equal to n, right, and then the delta star is 0. How is this possible? We run once, and subsequent runs, we increment delta star. And we say num stars is equal to n, which means num star is not equal to n, and then delta star is 0. How is that possible? The first one, I'm trying just to get a good solution out, right? So let's print my current t list. Okay, that's fine. And then inside here, we're gonna print t list. Yeah. And then print num stars. And then delta star. Num star is 3. Delta star. And res. Res is 2. How? Oh, I forgot to say change equals true. That was my mistake. I mean, 0, 0, 2 works. How many times are you going to change this, huh? They just keep changing it. Yep. So I think this one is easier for me to reason with. I think it's also going to be faster. Basically, I think we run once, and then we run another time, 2 times, and that shall be good. And if 2 times not enough, 3 times, so we do have to run to the end. So it's going to be slow still, but it's just it doesn't have, we don't have to like count on the end. But it's basically the same solution. I don't think this one will make too much difference. It's basically the same solution. I think this is the same solution. Yeah, it's basically the same solution. It's not going to change much. But I think it's actually performing better than the previous one. Just slightly better. Yeah, it's better than the previous one because we have some easier checks. So this is actually we're going to just write here. The same solution, but with slightly different implementation. We use, we count how many stars, count how many wildcards, that have been incorporated, and use that as the sentinel to determine when the runs shall end. Yeah. All right, that's it. It's a terrible, terrible day again. It's actually a pretty new question, I think. It's only 98 here. I don't want to look at any of this. That's that's it. That's it for today. 5 hours. We hit a new record, but we're not gonna give up. We're gonna keep doing this. I'll see you guys tomorrow. Adios.